Hello everyone, and from today we will be starting a new project called signature recognition. So as it is our problem statement, so clear from the name itself is signature recognition. So we need to recognize whether a particular signature is genuine or forged one. So let me read the problem statement. So the task of signature recognition involves building a system that can automatically recognize an individual signatures from a given set of signature images. So what we have to do, we have to build a system and that can automatically recognize whether that individual signature, okay, the signature that is provided to our system, and it has to detect whether that particular signature is genuine or forged one. Okay, so that's the solution that we need to propose. So we need to build the signature recognition and to develop an accurate and reliable system that can automatically recognize individual signature and distinguish it from forged signature. So that's the system that we need to build, and it should be very accurate and reliable one. Okay, and what is the use of this particular system, where we can use this particular system? So we can use this system in document verification, fraud detection, and biometric identification. So these three processes mostly, we can say that in the banking domain, this system will work. Okay, and people are using this kind of a system because nowadays everything is digital. So we need to detect whether the particular signature that is done by a person is original or is the fraud one. Okay, so for this project, the dataset that we are using is CICD signature. So it's a database of offline signatures for signature verification. So it's a complete database. Okay, and in this particular database, 55 papers were contributed. Okay, and they have done the signatures. Total number of signatures that they have done, genuine signatures that they have done, is 1320. And again the same amount of forged signature is also done by them as well, 1320. Okay, 1320 signatures were done by the 55 individuals. Okay, so that's the CICD signature database is there. And so the model that we are going to use here is that will be ResNet 34 model. So let me read this. ResNet 34 is a popular deep convolution neural network architecture that was introduced in the paper Deep Residual Learning for Image Recognition, and it is introduced by Keming He in 2016. So ResNet, so you can see that it's a very good one and very recent one, 2016 it is. And as it is a classification task, so for that we have to use this ResNet model. And you can see it's mentioned there, ResNet is having a 34 layers, so that's why its name is ResNet 34, including 33 convolution layer and one will be the fully connected layers. So the architecture of ResNet 34 is based on the residual learning framework. So that's about the problem statement. From next video, we will be discussing about the setups part, what will be our prerequisite for this particular project. Hello everyone, welcome back. So in our previous video, we have already discussed about the problem statement. So in this particular video, we will be discussing about the prerequisite, what all things will be required for this particular project implementation. So we'll try to explain you one by one. So first thing that will be required, that will be Git. Okay, so to install this one, we need to go to the Git SCM website. So this is the Git SCM website, and we need to go to this download page. Whether you are working on Linux, whether you are working on Windows or Mac, for everyone this downloadable link will be available here. Okay, so simply what we need to do, we have to just click on this download for Windows and it will be downloaded. Okay, and once it will be downloaded, you have to select you have to select which one, whatever is your system configuration, whether it is a 64-bit or whether it is a 32-bit. Okay, so you need to select accordingly. Mine is having 64-bit, so I'll just select this one, I'll save it. In my system it's already installed, so it's very simple step. You have to just click on that and you have to go click on next, and it will be done. So this will be the first thing that we need to have in our system for project implementation. The second one is Anaconda. Okay, so let me go to that particular portal or particular site, you can say. anaconda distribution is there. So this one is very much important. Let's suppose if you are working on a project, so we need to create a separate environment for that particular project, because we need different kind of libraries that we need to install it for that particular project, and this anaconda will help us to create a environment for that. Okay, so according to your system configuration, you can download it. It's Windows, Mac, Linux, for everything, every kind of a system it is available. So you need to just click on download and it will get downloaded, and very simple step for installation as well, like next step, and nothing you have to do. So this one is the second one, and the third one is the PyCharm. Okay, so PyCharm, why I'm saying PyCharm, because it's a IDE. Okay, whatever things that we are going to use, we have to write it somewhere, right? We can't use Notepad for writing complete projects, so we need an IDE to implement it. So I'll suggest you install PyCharm in your system. That will be much better. We have to just click on the download, and we it depends upon you which version you are trying to going to install, professional or community one. My suggestion will be you can go for the community for this particular project. You don't need to go for the professional version, because for professional version it will charge. Okay, how much it will be, so you need to check that how much they will charge. But for implementing this particular project, this community version will work fine. Okay. Hello everyone. So in our previous video we have already seen the setup part, like what all softwares will be required for this particular project. Okay, so in this video we will be discussing about the folder structure. What will be the folder structure for this particular project? So for that, as I already explained in the previous video, we need an IDE for that. So I'm just going to open the PyCharm. Okay, that's the IDE that we are going to use in this particular project. So let me open that PyCharm. Just give me a second, it will be open. So you can see this is the PyCharm window. Let me close the project that I'm working. So once you will open the PyCharm, you will see this kind of a window. Okay, if you are install the PyCharm first time, so these many project name you won't be able to see, but if you will be having some projects, so these are projects like that, you will be able to see the list of the projects. Okay, so what we need to do, we need to click on the new project, because we are going to implement a new project for that, and it will ask for the location where you want to store this particular project. So let me select the project. We have to just click on this particular location, browse file, and then this pop-up will come, and we need to select where exactly we want to store this. So I'll just go here and then create a new folder here, or maybe in this particular section only I'll try to create a new one. Okay, in this particular section I'll try to create a new project, and our project name is signature recognition. So I'll keep the name as it is. It will be signature recognition. So this will be our project name. And after that, one thing I have told in the previous video, we need to install Anaconda as well, just to create a new environment for that. So what we need to do, we have to create a new environment as well. So here the multiple options are there to create a new environment. So we'll go with the Anaconda. So it's a conda, it is mentioned there, and so it will see, you can see that C will be the part, and the environment name will be signature recognition. So this will be our environment name, and the Python version will be 3.10. So I won't suggest go for the Python 3.10. So for the time being, we'll go with the Python 3.8 version. Okay, now I'll click on create. Now wait for some time, and it will create a complete project, like a structure for you. Just wait for a few minutes. These are the very common errors, so don't worry about that. I'll let you know how to fix this error as well. Okay. So this you can see. So we have implemented the project. Okay, so this is the project name structure, or the structure we need to define. Okay, so once you create the project signature regression, so this will be the UI. This is the first thing that you will be able to see. They have created a simple Python code just to print a hi message, or PyCharm message, simple hi message is there. So we don't need this main.py as of now, but we'll keep it as right now. So what we need to do, we need to create the folder structure for that. So in the next video, I'll explain you about the folder structure, how we will create the folder structure in this particular PyCharm. Okay, hi everyone, welcome back. So in the previous video, we have already seen how we are creating a project in a PyCharm. So in this particular video, we will be discussing about the project structure. So how we will create the project structure. So it's very simple. There are multiple ways to do that. So I'll use terminal. I'll go with just selected the git bash thing, and then what I'll do, I'll just create multiple folders here. So first folder will be src folder will be there. Okay, in that folder, if you can just reload it, you will be able to see the src folder here. So this will be your main file. So whatever pipelines that you are going to build, so everything will be present in this particular folder. Okay, and other things, whatever other things are required, just give me a second, I'll let you know. Okay, so src is getting created. Okay, so in this one only we will be able to write all the pipelines. Okay, and apart from that, whatever things will be required, I'll create it one by one, and we have to follow this thing for entire project. Okay, so after that, what we have to create, we have to create a requirement file, and in that requirement file we will be writing all the libraries that is required for this project implementation. So if you'll reload it, so you can see the requirement.txt file is there. I'll mention everything like related to the libraries. I'll install it one by one, whatever packages will be required as will start implementing the project. So as of now, we are just focusing on the folder structure part. So we'll create one by one this thing. So requirement file is important, and after that, one more file is important, that is setup.py file. So for that we need to create, so that will be a py file. Just what we need to write, setup.py. so this file will get created. Let me reload it. So you can see setup.py file is there. So what we are going to write in this particular setup.py file, so let me write it. What all things will be required in this setup.py file, and what is the use of that. Let me write the code, then I'll explain you what is the use of this setup.py file. So we have to import some of the things in this particular setup.py, and that is setup tools. Okay, so setup tools will be there, and from that we will be importing find packages. So inside find packages, this will be there, and then setup will be there. So these things will be required. So what we need to do, we have to write the setup, and inside that we need to write few things. So what will be the source? Okay, so the source is src. Okay, so we are writing, like as we have mentioned here, src is the main folder, so name will be src. Okay, and version also we need to mention there. So what will be the version? So consider it 0.0.1. This is the first time that we are creating, so I'll create, and there will be a comma after that, else we'll get the error. And after that we have to mention the author as well. So who is implementing this particular project? So author wise, I'll write my name as of now, or maybe you can give your email ID as well. So there is no issue with that. So I'm writing my name. Okay, and author email also you can write, just author email. So I'll write my email ID. After that, packages we need to do, right? What all packages will be required for this particular project? So we need to mention there find packages. So what will be what this find package will do, that I will explain you once we'll write the requirements file. Okay, just for right now, you just understand whatever things will be written in the requirement.txt file, it will go inside this find packages. It will look for all the packages, and then there will be one more argument, install requires. As of now, we are mentioning the empty list, because the thing whatever things like this find package will check for the requirement.txt file, and whatever packages or libraries will be mentioned there in the requirement.txt file, and that will be installed. So this install required will take all the packages that is mentioned in the requirement.txt. So as of now nothing is mentioned, so we don't need to mention it. Even though we don't need to mention it, it will take it automatically by using this package name find package. So this will be the setup part. Okay, after that what we need to do, we have to just run a single command just to verify whether everything is correct or not. So we'll just write pip install -r requirement.txt, but it won't work. It will give you the error because in the requirement.txt file we haven't mentioned anything. So what we'll do, till now we haven't discussed anything about the libraries, but as of now we have written something related to the setup part. Okay, so that we need to do it. Okay, for installing this setup part we need to write -e dot, that we need to write. Okay, and then we'll install it. It will take some time and then it will install. So now we'll reload. So now you can see there is a file, this egg info file will get created. Okay, so next time whenever we are writing code inside the src file, let's suppose we are writing about any pipeline like ingestion pipeline or transformation pipeline, and we want to use that particular, let's suppose use that library. So whatever things we are going to write in this src file related to the pipeline data ingestion and all that, so that we will be able to import it in different pipeline as well. Like in data ingestion, if something we have written, some function we have written like initiate pipeline, or maybe if data is coming from the MongoDB to local like functions that we are writing. So and if you want to use that particular function in our different pipeline like data transformation pipeline, so that function being called that, so we can import that function by using that simple import command like from data ingestion dot that function name and import that thing. Okay, we will be using that. So I'll we'll discuss this thing in a very much detail. So that's all for this particular video. Hello everyone, welcome back. So in our previous video we have already discussed about the folder structure, and in this particular video we will be working with the Jupyter notebook part. So let me open PyCharm once and we'll start working with the Jupyter notebook. So let me go to PyCharm and open it, as I have already opened it. Until now we have worked on this part only. We have created the src folder, requirement file, as well as the setup.py file as well. Okay, so we need to work on the Jupyter notebook. So for that we'll be creating a new folder here. So I'll just click on open the terminal and we'll create a directory with the name of notebook. So inside that only we will be creating all the IPNV files, this notebook folder. Okay, and also at the time of project creation we have created our conda environment, so that environment we need to activate it. Okay, so what I'll do, I'll activate my base environment first. Okay, by writing command source activate base, and then I need to activate the environment for this particular project. I have created an environment with the name of SEG. So I'm activating that environment. In your case you can create your environment whatever name you have given, that name you need to mention here. Okay. Fine. So as we have to work with the notebook, we need to install the required library for that. So the command is very simple, pip install Jupyter notebook. As you can see here, is requirement already satisfied I am getting, because I have already installed Jupyter notebook in this particular environment. So it is showing is already satisfied. Now what I need to do, we need to write here Jupyter notebook so that we can start working on the notebook part. I'll simply start it and it will open in the browser. So you can see the folder structure that we have created in the PyCharm. The same folder structure is present here as well. Okay, and whatever thing that we are going to do with respect to the notebook or IPNV, it will be present inside that. So what I'll do, I'll create a new notebook here. Okay, I'll just simply select, and also I'll give it the name. So I'll give the name belongs to our project only, signature recognition. that I'm going to write it here and rename it. So you can see this is the notebook that we have created. Okay, now what we need to do, we have to perform the as we are. So now we will be discussing about the analysis part. Okay, what kind of analysis we have performed during this project creation. So that I will be discussing in this one. So I'll be writing code here line by line, and even though I'll explain it why we are using this particular thing. So first things that we require is we have to import some of the libraries that we are going to use in this particular project. So let me import some of the libraries. So the libraries that we are going to use in this particular project, that will be OS. First thing is OS that we are going to use. Let's suppose we need to change directory and all that. So we can change our directory by using this OS. And also, as this is a deep learning project, and for deep learning we used to go for the two frameworks. One is TensorFlow, another one is PyTorch. So in this one we are going to use the PyTorch. Along with that, also we need the NumPy library. So I'm writing here import NumPy as numpy, also pandas. So I'll write it everything, whatever packages are required. Put also matplotlib is required for some of the visualization stuff. Okay, and then from TQDM is also important for us. It's for the progress bar. You will be able to see like what is the benefit of using this one when we'll use that library in our code. And also we need that from torch.nn.functional, that also we are going to import. Inside that multiple functions are there, so that we are going to, so we have given its alias as f. So whenever we are going to call anything related to the functional part, so we will be using f dot the function name. Okay, so now I'll run this simply. That's the thing. So this is it's run successfully, but in your case it might fail because we haven't installed this library till now. The torch, numpy, pandas, matplotlib, tqdm and torch library, this library we haven't installed till now. So what I'll do, I'll show you what all packages are required for this particular project. So I'll mention everything in the requirement.txt file right now. So what I'll do, I'll just write it, just give me a second, the packages that is required for this particular project. So I'll simply, so these many packages were required for this particular project. Okay, so you can see TQDM is there, numpy, utils, Cython, pillow, pyml, pandas, Cython, pillow 2 times came. Okay, so let me delete this one. Jinja, FastAPI. For UI we are going to use the FastAPI. IPY kernel is there for Jupyter notebook part. OpenCV also we are going to use. Torch is there, that will be using, and DIL implementation and Python multipart, and Google Cloud Storage and Apache Airflow, that I will be discussing. Okay, when we'll start working on our pipeline part, what is the benefit and where we are going to use this thing. So this will be our requirements file. So these all we have to install in our particular environment that we have created. So our environment name is, let me activate that environment. I'll show you how you can install this thing. So let me activate the base, and then I'll activate the environment in which we are working right now, SEG. Okay, so once we'll activate this environment, so we need to install all the packages that is present inside the requirement.txt file. So what we need to do, and what we need to write here, pip install -r requirements.txt. So once I'll click on enter, it will install everything whatever is mentioned in this requirement.txt file. If I'll hit enter, just wait, it will be installed. In my case it will be requirement already satisfied because I have already installed everything in this particular environment. Okay, so these packages were required for this complete project implementation. But till now we haven't installed the PyTorch. Okay, as you can see, torch summary is there, but PyTorch we haven't installed. And why I haven't mentioned this thing in the requirement.txt, there is a reason behind that, because it will be different from it will be different system to system. Okay, my system is having CUDA, like I am having the NVIDIA GPU, so I need to install the CUDA version of PyTorch. But in your system, if you don't have a CPU, if you are having a CPU version only, you don't have a GPU, then you need to go for the CPU version of that. And how you will select that PyTorch, which version and which exactly which one you have to install, I'll show you that. Let me open the browser first and then we'll start. I'll explain you. So let me type here pytorch.org, and now here you can see we need to go for the stable one, and as I'm using Windows, so I'll select the Windows. And also we are going to use here the Conda environment, so Conda I'm selecting. Language wise, Python we are working with that, and in my system I'm having CUDA 11.6. okay, so because of that I'm selecting this one. So whenever so now I have to simply copy this command and run this particular terminal. Okay, I'll paste it here. Sorry, I think I did some mistake, sorry for that. Let me clear this thing. Yeah, so what I need to do here, I have to simply copy it from here and paste it here, or just paste it. So this is the command, and this command will install the packages, okay, like PyTorch related packages, and along with the CUDA. It will be installed in this particular environment. As I have already installed this thing in my system, so I'm not going to install this. Okay, but and one more thing is there, how you will be able to get to know like which NVIDIA or which CUDA version is present in your system. So there is a command for that, NVIDIA-SMI. So if I'll write it, hit enter, and then you will be able to see in my system it got give me a sec, let me execute it once again. Some part is missing here. Okay, or I'll just write it NVIDIA-SMI. okay, so you can see the CUDA version 11.6 is there. So I'm having 11.6, so I have gone with this 11.6 version. If you are having 11.7, you can go for that one. If you are having CPU only, you don't have any CUDA, then you have to select this CPU version of that. Okay, and one more thing is there Conda and pip is there, so we can go with the pip as well. Okay, there is no issue with that, both will work, Conda and pip. Okay, anything you can use it, and you'll get the command here to install that package and you will be able to install it. So that's the requirement part. Now we'll go with the Jupyter notebook part, like what all things we need to perform in the notebook. So we will be discussing about that. So these are the required packages that we need. So what I'll do one thing. I'll create a markdown here and I'll write it importing libraries. So the libraries that is required for this particular project. So importing the libraries. So like that. Okay, some markdown that we have created. Now what we have done, we have imported the libraries that is required for this particular project implementation. Now the next thing what we need to do, we need to find the where exactly this data is. Right now I'm keeping this data in my local system. In future, when we'll be discussing about the pipeline file, we'll keep this data to the Google Cloud storage and we'll fetch the data from there. Okay, in our data ingestion pipeline. So right now I'm simply giving the path of the data in my local directory. So what I'll do, I'll just keep the data. Okay, so what I was saying, I will keep the data as of now in our local directory. So what I have done here, Let me open PyCharm and I'll show you what I have done. So I have created one folder. Give me a second. I've created one folder. Let me reload it. Folder inside our notebook, okay, with the name of data, and inside that data I have kept the data like the forged and original. So as we have already discussed in our problem statement that we will be having two classes in this project, signature recognition project, and the classes will be forged or original or genuine, whatever you can say. Okay, so as of now I'm keeping this in the local. In future we will be keeping it on the Google Cloud storage. Okay, so now what I need to do, I'll have to just mention the path where this data will be kept. Okay, I need to just give the path of that root directory. So let me write it first. Let me create a markdown, and inside that I'll write root data directory path, and also I need to mention the directory path. So data directory will be there. So let me give the variable name data directory, and I need to give the path of that. So if you can copy the path from here itself in the PyCharm, so what we can do, we'll just simply click on the data and we'll go to the copy path. Okay, I'll copy the complete absolute path of it. Okay, I have copied it and I have to paste it here. So I have pasted. Keep R here. So as we are working on Windows, so there might be a possibility you can get some error related to paths, so we have to keep it R. So that's the way. So now I'm not getting any error here. So now I will check how many number of classes are present in this particular data. Okay, so it's very simple that we need to do. I'll just create a markdown first. I'll write it total number of classes that we need to find it here, and for that we are going to use the OS library. So OS library, what it will do, os.list directory. So inside this path, on the number of directories it will count, and it will tell us number of classes, the number of whatever the number of folders will be there inside data. Okay, that will be the number of classes. So as we can see, we are dealing with the two classes. It's a binary classification problem. Okay, now we need to import some of more libraries. Okay, so I'll just simply import it. Torch vision dataset image folder is there, even the data loader is there. I will be discussing about these libraries when we are going to use it. Okay, so but these libraries are very much important for this particular project, and that we are going to use it. So let me run it simply, and we will be able to see like it's working. Let me generate few cells. Okay, and also make the I'll make it bigger, the font. That will be much better. Now what we need to do, we have to check whether our system is having CUDA or not. Okay, so I'll just simply go to create a markdown first. We'll writing checking the CUDA availability. Okay, and for that the code is very simple. So what we need to do, torch is the libraries that we have imported, is for PyTorch library, and inside that device is a function. So what we are doing here, we are writing a if condition inside that. If torch.cuda.is available, then return CUDA. Okay, else CPU. Okay, so once we'll run this cell, so whatever device will be present, like let's suppose if I will be having CUDA, so it will simply return device CUDA, else it will return CPU. So let me run it. So it is returning CUDA. That means I am having CUDA, so I am going to use the NVIDIA GPU here. Okay, so now the next step is we have already got the data. We know that how many number of classes are there in this particular data set. Now we need to transform our data. Okay, basic transformation steps we need to perform here. So let me write markdown here, and in the markdown I will be writing the transforming the data that we are having. Okay, and how we will be performing the transformation, so I'll explain you that right now. So now you can see that data transformation variable have created T. So what is this T? You can see from torch vision import transforms. Okay, so whatever transformation techniques are available in torch, that is present in this particular function. So when we have imported this particular function, and inside that all the transformation are available. So what we are going to do, transforce.compose, and inside that what kind of a transformation that we want to perform, that we are writing. So first thing is that we are resizing our image to 24 cross 224. That's the image size. So we are resizing the image to be 224 by 224. So that's the thing, the simple resizing operation that we are performing. And after that, what we are doing the random rotations, like the images, maybe it will be tilted or something. So randomly we are rotating image by plus or minus 20 degree. It's a kind of image augmentation. Okay, wait, I think augmentation. Okay, it's a image augmentation for each epoch. And after that we are converting the images to tensors. You know that we are dealing with the torch. Even in the torch we need to convert the images into tensors. Okay, so converting the dimension from height, width and channel to channel height, width conversion of the PyTorch. So when we are converting into the tensors, so normally what happens, the images will be in the form of height, then with weight will be there, and then channel will be there, right? But when we'll convert it into the PyTorch format, so PyTorch expect it in the first, the channel will be there. Let's suppose if it is a RGB image, okay, colored image, then channel will be 3, but in our case the channel will be 1 because the images are gray scale. Okay, so that's the thing. And after that we are performing some normalization, like related to the 3 means or 3 standard deviations of image. So simple normalization we are performing, and now I'm just going to run this cell. Okay, so it's done. Okay, so this is the transformation things that we are going to perform when we will be training our training our model. Now what we need to do, we need to count as well, like how many number of data if you want to check it. So there are few commands, are like few code is there. So we are just simply, if I'll run it, it will give you the total count. Okay, so if I'll print the total count, so you will be able to find it. So this is the total count, total number of images are present, okay, in our data set is 2640. So as we have already know that we are having 2 classes, and each class is 1320 images are there. Okay, so if we'll add those 2 classes, so images will be of 2640. Okay, and if you want to check the name of the classes that is present, so what we need to do, simply we need to write it data dot classes. Okay, we'll write it. So these are the class name, forged and original is there. Okay, so that's all about the transforming the data. Now we will be discussing about the splitting the data. We need to split our data as well. As we can see, we are having a like a data in a single folder. Okay, it's not split, so we need to split it into train, test or valid. So we will be performing that now. So let me keep it in the create a markdown right now, splitting the data. Okay, now how we will be splitting the data, let me run it. So what we are doing here, okay, train count, valid count, test count, how we are going to calculate it. So what I have done here, so as we know that total count is 2640. So I'm just doing a multiplication with 0.6, like 60% of data we are taking it in the training, 30% for validation, and the rest, the remaining images will be present for the testing data, and remaining will be 0.1. Okay, and after that what we are doing, we are splitting the data by simple using library torch.utils, and inside that data is there, and then random split. So data will be splitted randomly, there will be a random shuffling and everything will be there. So and we need to provide the path of the data, the root directory path. so the data we have provided, and even the split ratio we need to perform. So train count is of 60%, value count is of 30%, and test count will be for 10%. So if I'll run this one, then you will be able to find. So we have already splitted our data. If you want to find it, so if you'll write it, train data dot dataset, if I'll write it, so you will be able to see. So dataset is type of image folder, and number of data points is 2640. Location is notebook data. So it's all about the train data points is there. So it also perform. So if you want to check whether the data is being splitted or not, so we'll simply call train underscore data dot indices and then length. So if we'll write it here, so the image total number of images present in the training set is 1584. Same thing we can do it for the test as well. So simply write the same thing, 260 images is 264 images are there, and for valid as well, valid data, I think it's val, yeah, 792 images are there. So we have successfully splitted the data. Okay, now we will be defining some of the functions that is required for this particular project, like as we are going for a visualization of stuff, so we will be needing some of the functions. So I'll just write those functions and then explain you what is the use of this particular function. So this is the function that I have created here. So I'll be explaining these functions. Three functions are there, so I'll explain it one by one. Okay, so as it is clear from the name, show image. Okay, so by using this particular function, we will be able to see the image. Okay, which image is present here along with their labels. Okay, so image is there, it will get not denormalized, and then it will show the image. So let me run it. Okay, and then you will be able to see it very clearly. Okay, that will be fine. So what I'll do, I'll just call for this show image function, but before that, what I need to do, this show image will take image as well as label as a parameter. So I need to take an image from our training data. So I'll go with the training data and I'll take the first image from that, and that first image index will be containing the image as well as the labels. Okay, now I need to call the function show image, and inside that I need to pass the image and the label. So if I'll run it, so you can see this image as I already discussed. Okay, so image is there and its label is also there. It's written there, it's a signature, you can see that. So it's a training image that we have created. So that's about this function. So, and after that, show grid function is there. So if we'll use this show grid function, so this image will be present in the grid format. There will be separate lines. So as of now, I don't think we are not going to use this particular function. So what I'll do, I'll simply delete it. Okay, there is no use of this. Okay, but accuracy that we are going to use, and when we'll talk about when we'll go for the model prediction, so that's what we are going to use it. So we'll keep accuracy as it is. Okay, so that's about the functions. Okay, so function is there, and after that we will be discussing about the data loaders. So what we have done till now, we have taken the data, we know the total number of classes, we have checked the CUDA available is in our system or not, then we have transformed our data, splitted our data, and some functions we have created to show the image, so any image. Now we will be working with the data loaders, and what is the use of that I'll discussing. So let me create a markdown first and write it here, data loader. Okay, so data loaders I have written, and what we will be going in doing in this later order, I'll explain that. Okay, so data loader is a function present in the PyTorch. So as we have already imported this one, so you can see inside torch.utils.data, data loader is there, and this data loader will take parameters like train data. So train data, the number of training data, whatever number of training data we are having, that it will take, and after that batch size it will take also, and shuffle if you want to shuffle your data or not. Okay, for training and validation we are shuffling our data, but for testing we can skip it. Okay, so we'll make it false. We don't want to shuffle our data for testing purpose. Okay, but for training and validation it's good if you will shuffle your data. So in that way training will be better. Okay, so it's nothing what we have done here. We are creating a train loader, validation loader, and test loader. Okay, and inside that we are passing the batch size, shuffle, and the train data path. Train data path for train loader, valid data path for the validation loader, and test data path for test loader. So when we'll run this one, so you will be able to find the number of batches and number of examples. It's very simple. So how many now when we'll call the train loader dot data set, so we will be able to see, so these many number of images are present for the training, these many number of images are present for the validation, and 264 images are present for the testing. So that is the use of data loader, and this data loaders will be passed to our model when we'll go for the model training, and these data loaders will be required for that. Okay, so this is all about the data loaders. Now what we need to do, we need to create the model, or maybe we can say that as we are going to use here ResNet 34 model, so the model is a kind of a transfer learning technique that we are going to use here. So what I'll do here, I'll just create a markdown first with the name of model. Okay, and few more libraries that is required for creating model. Torch is there, torch neural network is there, then functional. Optimum is for optimizer, torch vision that we are going to use, even for transform. Transform, I think we have already used it, so even we can skip this part. Okay, so that we can leave it. Some more imported statements are required, so let me import those things. Okay, yep. One thing is there, model is missing, so let me import that one as well. That is present inside the torch vision. Let me delete this one. We will be requiring torch vision import models, and then we'll run it. So now we have imported all the libraries related to model creation. Now we need to create the model. I know we are going to use the retained model, or you can say the transfer learning model. So the model that we are going to use here, that will be, we are going to use models.resnet 34, and the type, sorry, and the type will be, we are going to use it pre-trained model. No? So this will be pre-trained is equal to true. Okay, and we'll keep assign it to a variable called model. Okay, so it's the model we have done. Now what we need to do, so this is the model we have loaded, this is the ResNet 34 model we have loaded, but we need to do some changes in its last layer, because ResNet model is trained on the 90 classes of dataset. Okay, but in our dataset we are having only 2 class. Okay, so we need to change accordingly. Okay, so for that we have to use this thing, neural network dot sequential. At the last layer, what I'm doing, I'm using a dropout layer. Okay, so 0.1% of data will be dropped out, and then in the linear, in the last layer, what we are taking the input features, whatever input features, and the output will be the length of class name. And the class name is what, as we have already mentioned here, the class name. Okay, this one, the number of class, the class name variable is having 2 values. Okay, so this will be our class name, So output that we will be having will be binary. Okay, so two output will be there. So if I'll run this one, that's fine. Now what we need to do, model is loaded and we have already filtered the last layer, already updated the last layer of our RESTnet model. And the criterion, so this is the cross entropy that we are using here, that is cross entropy loss, and optimizer wise we are using SGD optimizer. Model parameters we are using, and the learning rate is 1 is to 1e-3, that learning rate we are using, and momentum is 0.9 that we are using here. So now we are good for the model training. So but before that, in PyTorch we need to create a function for model training. Okay, so I will be creating that function. So this is the function that we are creating for model training. So we are getting a function with the name of train. Okay, and it will take the parameter as model. Criterion is nothing, just a loss. Okay, this is the loss that we are using cross entropy loss here, so this will be the criterion for that. Optimizer wise we are using the SGD optimizer, and train data loader is the training data set we are using, that will come from this part, the data loader part, and then test data loader will be here. So what we are doing, we will simply call model.train, and we are creating two variables here, and we are assigning it 0 as of now. But when that model training will start, this values will get updated. Okay, and TQDM is just a progress bar. For progress bar we are using that, and train data loader will be passed through that, and unit batch, so it will depends upon the batch. Leave is equal to false. So it's just a description because it is used for the training, so this particular code will be used for the training. And what we are doing, this p bar is there. P bar will take image and their IDs, and then image will get converted with respect to the device, because that in the device we are having the CUDA compatible devices is there. If in your case CPU will be there, so it will be get converted into the CPU base. Then that image will pass to the model, and the loss and the training loss that will get updated after training each and every epoch. So that is in the this is in the training part, and in the testing parts it's same, nothing is going to happen here. Even the test data will be there, and the leave will be false here. Image will be again passed to a CUDA. Okay, if your device is having CUDA, then it will be, then model will be passed, and it will calculate the loss as well. Okay, so this will be your for calculating the loss when we'll train the model. So you need to find out, so what kind of accuracy and what kind of a loss you are getting with respect to your model. To know about that, we are creating this functions, or not, you can't say this function, this line of codes we are creating. So I'll simply run this function. So train. Now what I need to do to run this, to start our model training, simply, so what I have done, I have imported time here just to check how much time it is taking for model training. Epoch wise, I'm just going to train it for 5 epoch, or maybe less than that. I'll do that because it may take more time. Okay, so what I am doing, for I in range of epochs. Okay, so epochs will get printed, like let's suppose that when it will come to the first epoch, the epoch 1/2 will be there, because the maximum number of epoch is 2. Okay, then it will go to the train function, then model will be passed, criterion, optimizer, and train loader validation. So once I'll run this cell, our training will start. So as I have run this cell, you can see the training is 0%. It will start. You can see now it got started. It will take few minutes to train our model. So in that way training will start, and you will be able to get the training loss and test loss. So what I'll do right now, so I'll close this video till this part only. In next video we will be discussing about the prediction in notebook. Okay, because it will take some time to do that. Okay, so that's all for this video. Hello everyone, welcome back. So in our previous video, we have already started working on the Jupyter notebook part, and till now we have completed till the model trainer. Okay, so we have already trained our model. Now the thing is that we have to save our model as well. Okay, the model that we have trained, we need to save it as well. So let me create a markdown first, and then I'll write there model saving. How we can save the model, so that also we need to know. So model saving, and for saving the model we need a path, like where exactly we want to save the model. So what I'll do, we'll save the model in our current working directory. So if I'll write pwd and if I'll run it, so you can see right now we are inside our notebook folder. Okay, so I want to save it in this particular location as only. So I'll just copy this location from here and paste it here, and also I need to write r there. After that, what I need to do, I need to write the model name as well, at which name we want to save the model. So I'll give the name model.pt. So it's a PyTorch based model, so I've written there model.pt. Now to save it, we need to write torch.save, and then we need to pass the model object, object. So this is the model object. If you can see here, this model is there, right? So this model object we need to pass it here, and then we will be passing the path as well. So path is that. If I'll run it, so you can see now the code runs successfully. Now we have to check whether this model got saved or not. So we'll just click here and see in the model file. So in this notebook file, model.pt is present here. So the model that we have created right just now, like the trained model that we have saved it. Okay, now the time for load, how we will load this particular model is, okay, so that also we need to know. So loading torch model, make it markdown, and then if I'll run it, let me generate few more cells. So just to load the model, what we need to write, we have to give the path inside torch.load. Okay, inside that we'll give the path of our model where exactly it is, and then it will get loaded again. So you can see that the model is loaded now. Okay, so what we have seen till now, so we have seen how we can save the model and how we can load a PyTorch model. Now the time for the model evaluation. So we have done with the saving, training and loading model, though then we need to understand as well, like what is the evaluation, like what is the accuracy and what is the loss we are getting with respect to this particular model. So for that we have to perform evaluation. Okay, so if I'll make it markdown, and then I'm just going to write the evaluation code, how we will evaluate the model. So the it's very similar to the training code with little bit of modifications. So what it will do, take this evaluation will take the model, okay, and the criterion is nothing but it's a loss function. Okay, and this optimizer and the test loader. Okay, we have created three type of loader, data loaders: train, test and valid. So for evaluation we are going to use here test loader, and there is a variable we are taking just zero values. We'll add values inside that in this one. So we are in TQDM we are passing the test loader, and unit will be batch, just like the training part. Nothing else we are doing, we are just simply passing doing same thing, whatever thing we have done in the training part. But here we are just trying, we are not going to train our model, we have to just get the loss out of it. So if I'll run this cell, it's got executed successfully. Now I need to provide this now I need to call this particular function. So evaluate, I am calling model giving, criterion, optimizer and test loader. So if I'll run it, so you can see this one it's running now. That our test loss is 0002.0002, that is the test loss. It can be decreased as well if we will train our model for longer duration. Okay, so that's all about the evaluation part. Now the last thing left, that is prediction. How we will do the prediction with respect to this particular model. So let me create it. So just to go with the prediction part, we need to know what all label names we are having. So if I'll write label names, and how we will be able to get the label names, so we are having data, right? And if I'll write data dot classes, then, and if I'll write label name there, then you will be able to get the outcome forged and original, this one. If I'll run it, so you are able to get, so these two values are there, like these two classes are there, right? Now what I need to write, we need to perform prediction. Okay, so for that, what I need to do it, let me explain you that. Let me write a code for that, and then I'll explain you what we need to do for that. So let me delete it because we need to pass the image location here. So it's very simple. We are importing a PIL library, so it will help us to load the image, okay, from the directory, or if you are, when we are using the UI part, then from there also we will be loading the image, okay. And this image will be help to this PIL library, or you can say the pillow library will help us to load the image. Once the image will be loaded, then what we need to do, we need to perform basic transformation like resizing, grayscale conversion, and also we are converting into tensors, right? So these are the pre-processing steps we have performed. Then we have unsqueezed the image with respect to the device, because device, as we are going to use here CUDA, right? So we have to make that torch, like whenever tensors got generated, it in PyTorch, what is happening when you are generating the tensors with CPU, or when you are generating the tensor with CUDA, so both of their values will be different. So we have to, as we are using CUDA as of now, so we need tensors that is compatible to CUDA, okay. So that's why we are converting it here. And then again, this image is we are passing to our model, and then it is giving us the prediction. So what I'll do, I'll just simply copy the path of one image from this particular folder. So let me go here, go inside this one. What I'll do, I'll just copy the path of it, okay. And it will be better if I'll go to this path location through browser file explorer. So let me open that as well. So it I have kept it inside my projects, and inside notebook data is there, and then original. So what we'll do, we'll copy this particular location first, okay, and we'll paste it here. And also we need to give the name of that particular file which you want. So I'll just copy this file name, okay, and I'll paste it here. Now if I'll run it, so you can see the prediction label name label is 1, and prediction class name is original. So as we have taken the image from original class only, okay, so and our model is also predicting it original. So that means the model that we have trained, it's somehow somewhat giving us a good result, even though for this particular maybe for different image it won't get good result, because we haven't trained our model that much till now, okay. So that's all about the notebook. So maybe from next video we will be start working on the pipeline part, okay, and there we will be working on the IDE, complete IDE. Hello everyone, welcome back. So in our previous video we have already explained the complete Jupyter notebook part. So now the time for the our first GitHub commit. So what we will be doing, we will be creating a GitHub repo. As I have already told you, you need to install Git SCM in your system in our prerequisite video. So you can watch that video and you have to install that Git SCM from there. Okay, so if you forget that, I'll just write it here. So Git SCM downloads. So you need to download depending upon your OS. Okay, mine is having Windows and I have already downloaded this one. Okay, fine. So now the time to create our GitHub repo, first GitHub repo, and we need to post the code till now, whatever we have done. Okay, so what I'll go to the GitHub. I need to sign in there. So I'll just sign in into my account, and what we have to do here, we have to click on the repository. new one, and as our project name is signature recognition, so I'll be writing that name only. Try to write the name in the small later, so that's good. Okay, and I'll try to make it public for as of now, even though I want to add a readme file. Gitignore will be also there. For that I need to select the Python related gitignore file will get created, and license wise I'll simply create a MIT license. It's an open source, so you can use it. Now I'll click on create repository. So our repo got created. Now you can see this one, the repo is got created. Now we need to connect this repo to our PyCharm. Okay, so what we have to do simply, so we will be going to our project. So this is the project in which we are working on. Okay, so what I'll do, I'll just click on the terminal and then select the git bash from here, and then I'll write git init. Okay, so I have just initialized here get part. So if you can reload it, you won't be able to see any kind of a changes here, but if you will go in this particular folder location, the project that we have stored. So if I'll click on the explorer part, and if I'll go inside the signature record, so you will be able to find this .git folder will get created there. Okay, .git. So let me zoom it. If I don't think so, I will be able to zoom it. Keep it in the detail format. Okay. Yeah, so a git folder will get created whenever you will write git init. So it will initialize a empty git repository in this particular location. So in this particular location our project is there, and inside that a .git folder is there. Dot is there, that means it will be a hidden folder. Okay, so that's it. So we have already initialized our git. Now we need to connect our git to the repo that we have created. This is the repo that we have created. We need to connect this, right? So till now we haven't connected. So we can, how we can check it whether our git is connected to any repo or not? So for that we need to write here git remote -v. So I'm not getting any kind of a response here. That means our git is not connected with any repo till now. So to connect our repo to this particular GitHub repo, we have to click on this code one, and then this copy URL. Then we'll go to the PyCharm and then write git remote at origin, and we'll paste the URL that we have copied from there. We have to simply hit enter here. Okay, we have hit the enter here. Now it is connected. Now if I'll write git remote -b, so you will be able to see this repo is getting connected. Now we can fetch or push something to this particular repo. So let me clear it out. Okay, now what I need to do, we have already done this git setup up. We have already connected this particular project to our GitHub. So what we need to do, you can see in our GitHub there are few files already present there, and these files are not present in our PyCharm. Okay, so whenever we are initializing git or connecting our git to any repo, first we need to pull the data that is present on the repo. But for that we need to write a command git pull origin main. You can see the main. Why we are going to write main here? Because the branch here is main. Okay, branch here is main, and if you can check in your PyCharm, it's showing master, it is mentioned. So first we need to change the branch. So the command is git branch -M main. So now you can see the branch got changed. Okay, now we need to pull everything from the GitHub repo. Okay, so git pull origin main. Okay, sorry, there is a mistake. There is an spelling mistake. So if we'll write it git pull origin main. So it's done, it's successfully done. Now if I'll refresh this one, so you will be able to find this readme license and git ignore file here as well. Okay, so let me refresh it. I think it's refreshed now. You can see that git ignore file is there, readme file is there. You can see this one, signature recognition, git readme file is there, and also one more file will be there, git ignore setup dot, yeah, license will be also there. Yeah, you can see that license. Yeah, this is the license. Okay, it's already there. So a few things we have to mention inside this .git ignore. You can see here inside notebook we have created a data folder, and we don't want to push our data on GitHub repo. So for that, what we need to write, we need to mention this folder location, so that whenever GitHub will skip this part. Okay, so what I'll write, I'll just write notebook then slash data. So if I'll write it there and we will reload it, you can see now it got in the red mark is there. So that means this folder will go won't get pushed to our GitHub repo, along with this egg file as well, right? Egg info file is there. Even this folder won't get pushed to our GitHub repo. Now the time to push this complete thing on GitHub. So first command will be git add space dot. Okay, so whatever changes you have done, so it will get reflected to the GitHub. This is the first thing that we need to do. So we have to add all the files to GitHub, and then we need to commit as well. And for committing, before committing, we need to write a message what changes we have done in our GitHub repo. So till now we have completed till the Jupyter notebook. So I'll write the message Jupyter notebook done. This is the commit that we have. So these many files will get pushed to our GitHub repo. You can see the files name, 11 files got changes, 6383 insertions are there. So these many files will get pushed to our GitHub repo. So now we need to simply write git push origin main. I have to wait for that. Now it's successfully executed. Now if I'll go to this repo and simply refresh the page, so you will be able to see the notebook is there, and also you can see there is no data is there. Data folder is not there because we have already mentioned that data part in our notebook slash data, so it's not going to push on the GitHub. And even though it's not advisable to push your data on GitHub repo, it's not good. So this is for this video. Hello everyone, welcome back. So in our last video we will be discussing about the GitHub. We have pushed our code to the GitHub. So in this particular project we will be discussing about the pipeline part. Okay, so before discussing about the pipeline, so I need to explain you a little bit about the folder structure as well. So what all things will be present inside the SRC. So as I told you, so whatever things that we are going to write like related to the pipeline part, it will be present inside the SRC folder. So what all things will be present inside the SRC folder that we are going to create in this particular video. Okay, so inside this SRC folder there will be multiple subfolders will be there. So I'll be creating this thing one by one. So I'll simply use the command mkdir, and the folder that I need to create is components. Inside that only I'll be writing all the pipeline stages like data ingestion, data transformation, model trainer, model evaluation, and model pusher thing that we will be writing in this components. Okay, and there will be again another folder with the name of configuration. Okay, so that folder will be also there. So what I'll do, I'll create a folder one by one in this particular SRC. So I'll write mkdir src then components. Okay, components. So now if you can see here it will get created. It's very simple. Okay, components are getting created, and after that there will be a different folder. I'll simply press the upward arrow button to get to the previous command that I have executed, and I need to just write the folder name. configurations, and inside that all the configuration related stuff will be there. Like let's suppose we have to fetch the data from Google Cloud. Okay, so all the configuration related to the Google Cloud setup, that will be present inside this configuration. Okay, and after that one more folder will be there, that will be constants. So there will be some parameters or some values will be there that we will be using throughout the project, so that we are going to write inside the constants. Okay, and after that we will be using something in the entity as well. Like two types of entity will be there, one will be the config and one will be the artifact. Okay, we will be discussing this thing in very much detail, so as of now it's just about the folder structure, so I'm not going in that depth. After that we will be having our own custom exception, so I'll be writing everything in exceptions file, and also we will be having our own custom logger as well to log the information that we are going to perform. Okay, and this one will be the pipeline. Okay, so two kind of pipeline will be there, like training pipeline and production pipeline will be there, so that will be present here. And some basic utils will be there, like some functions that will be required throughout the projects, so that will be get created in this utils folder. Now everything is done till now. Now one thing we need to add in each folder, that will be init file. So as what we are doing here, we are creating this src as a library. Okay, whenever we are writing the command pip install -e dot, so it will create a library just like a pandas library. So inside pandas, what it is, whenever we are using pandas dot read csv, read underscore csv, so read csv is a function that is present inside the pandas library. So even though this src will work as a pipeline, sorry, as a library, so for that we need to create a init file inside each and every folder that is present inside the src folder. So what I'll do right now, so I'll just write touch. To create a file, any kind of a file, we have to use this touch command, but make sure this touch command will only work on the git bash, it won't work on the cmd. Okay, so if you are not having the git bash, so you have to create it manually. You have to go to that particular folder location and then we'll just create this file. Okay, so I am using the git bash here, so I'll creating this one. So you can see that it's got created here inside that src. Sorry, it's got created outside the src, so we are not what I'll do, I'll delete it, it's not required here. I have to create it inside that. So I forgot to mention the folder name, so src will be there, then slash, then this one. So now this will get created inside src init, and the same init file will be get create we have to create inside each folder. Okay, so for a very it's not possible to write everything here for command, we can create it, there is no issue with that. So the simple way will be we'll just go to the explorer part, like files will be open, here it is. So we'll go to the src, this init file is there, we'll just simply copy this init file and one by one we'll paste init file inside each folder. I'm pasting everywhere. Okay, fine. So this is the thing we left in that project setup part, folder creation part, that was the left. So we have done this now. Now we are ready for the pipeline discussion. So in our next video we will be discussing about the data ingestion pipeline. Okay, so I'm going to end this video, and before going to end this video, what we'll do, whatever changes we have done, we'll push it to the GitHub as well. So we need to write the command git add dot, okay, and then git commit -m, and the whatever changes we have done changes in the folder structure. So we'll write the message here, changes in folder structure. Okay, these many changes we have done, then we'll push it to GitHub. Git push origin main. So it will be pushed. If you want to check it, we have to just open our GitHub. I'll open it. I'll go to the repo. I'll open this one. So you can see that we have just now done the changes. You can see the commit name, changes in the folder structure, and in every folder you will be able to find this in .py file everywhere. That's that. So that's all for this video. Hello everyone, welcome back. So in this particular video we will be discussing about the exception. Okay, so we are going to create our own custom exception. So let me open PyCharm and then we'll start coding. So this is the project signature recognition. We are working on that. So in the previous video you can see we have already arranged our modified our folder structure. So inside exception folder there is a init file is there, so we have to open that init file and we have to update, like we have to write our own custom exception inside that. Okay, so for that we need to import a few libraries. So first will be import OS and second will be sys, is related to system. Okay, now what we need to write, we have to write a function. Okay, we have to create our own custom exception, so we will be writing functions that will generate our own custom exception by importing the exception library. As we already know, in Python exception is a library that is by default present. So by using that particular library we will be creating our own custom exception. So the code will be like that. So I'm just writing the code here. So this will be the code for custom exception. So I'll explain it what we have to do here and what exactly it is. So what we have created a function with the name of error message detail. Okay, and inside that we are taking a parameter error and error details. Okay, okay, so in this particular function we are taking a parameter error and error details. That how we will get this error and error detail, that I'll explain it. So error detail, so how we are getting it. So if you can see in this custom exception class that we have implemented. Okay, so the super class is exception, so this exception is already present and in the, it's a built-in function. You can see that it's a built-in function in the Python, and this is the to create a custom exception we have to take it as a exception as a base one. Okay, so to error details will be passed like this one, error detail message and error detail and error detail. This will be the parameter, and how what this error detail will be, that will be discussing. So what is mentioned here. So error detail dot execute info. So in this error detail dot execute info will be having all the error information. So the error we are getting, like let's suppose whenever we are getting any exception, so we are getting the line number and which at which time, which file exactly we are getting the error. So what we have to do, we have to segregate those things. Okay, so that it will be easy to understand whether exactly where we are getting the error. So what we are doing here, we are just taking it. Okay, we are just taking the information from this error detail and we are keeping it in the format of this one. So whenever we'll get the error, okay, whenever the exception will raise, so the error message will be error occurred Python script name. So inside this Python script name, like the file name, so let's suppose we will be having some main.py or maybe app.py will be there. So that file name will be print here. Okay, and inside that at which line number, let's suppose the 10th or 11th line number we are getting the error. So we'll get the line number from here, and after that the error message, what kind of error it is, value error or import error or module not found error or something like that error will come. So that error message it will be there. So by using this custom exception we will be able to get a segregated error message from there. Okay, and how we will get the segregated message, because of this error detail. In error detail, we will be having a execute info function is there that we are using, and from that we are taking the execution table. Okay, and from that table we are trying to extract the file name and the executable the table, and exactly which line number and what exactly the error is that we are able to extract. So this is all for this custom exception. Hello everyone, welcome back. So in our previous video, we have already discussed about the custom exception. So in this particular video, we will be creating our own custom logging as well. So let me open PyCharm and then we'll start coding. Okay, so inside logger, init.py file is there. So I'll open that, and everything we will be writing in this particular init.py. So as we have in the exception as well, we have used the built-in exception as a super class. So same thing will happen here as well. So we are importing logging here, and also we are importing OS. Okay, and also whenever also we are importing the date time. Why we are importing, I'll explain it. So let me import from date time, import date time. Now what we need to do, we need to write the log file name. So the log that will be generated with the file name. So the what will be the name of that particular file. So that's the log file name. So it will be generated with the current date time. So I'll write it. It will be date time dot now. So it will take our so whenever we are running the project, okay, or whenever we are running the pipeline, at that time the current time date time will be taken. Okay, and what will be that format? So for that strf time we need to mention there, and inside that we will be getting the time with respect to the m underscore percent d, and then score percent y, so month, date and year. And after that also we will be requiring the hour and also minute and second percent s. So this will be the file name, and after that the log. So this will be the extension. So there is a mistake here, it will be date time. So whenever the log will get generated, the file name will be with respect to your current date time, and the date time will be with first letter will be of your month, and then date will be there, then year, then at which hour, then minute and second, and dot log. That will be the extension of your log file. Okay, and also we need to make a directory for that. Like whenever the log will get created, it should be stored somewhere, right? So we have to create a log folder for that. So os.makedir is used to create directory, and inside that we are writing os.path.join. So what it will take two parameters. So first will be os.get cwd, so that's for your current working directory. So in your current working directory there will be a folder with the name of logs will get created. And let's suppose if we have to run the pipeline again and again, so multiple times we don't need to create the logs. Okay, so that's why a parameter exist, okay, is available. So let's suppose if the log folder will be present there, so it won't get executed, it won't create that. Okay, so now we need to find out the log directory path as well. So I'll write it, log directory path. So what is our log directory path? As same as this one, os.path.join, this one. This will be our log path, log directory path, where the logs will be stored, and log file path as well. So what is our log file path? That also we need to write. So log file path will be, again we'll write os.path.join. So log path will be log directory path. So it inside log there will be a folder will get created with the name of log, and inside that the file name. Okay, so this log file will get generated. It's with your current date time dot log will get created. So this will be your log file path. Now we need to return, like now we need to define in which particular format it will store the log inside the log file. Okay, so what I'll do, we have just imported the logging. So inside logging there is a module named basic config. So inside that we need to mention there the file name. So in which file name exactly we want to store our log. So the log file path we have just mentioned here, and the format also we need to define it. What will be the format, like what will come first, whether the date will come first, whether the name will come first, or whether the message will come first. Okay, so what we are suggesting, like if the date will come first, that will be much better. So what we are writing, for writing date we have to mention like that, percent asc time. Yes, so in that way date will be get mentioned first, and after that name will be printed there in that log. So we need to write name. Yes, and then after a hyphen we will be print the level. Okay, which level of the message it will be. So we'll just write the level name. Yes, also we need to mention, and after that the message will be there. So whatever things we are going to log, let's suppose we are done with the ingestion pipeline. So in the logging.info, if we'll write the message, data ingestion pipeline got completed, so same message will get printed in the logs as well, .log file, but it will be get printed first, the time will get printed, then name, and then level name, and then the message. Whatever message you will write, that message will get printed. So that's the thing. After that level we have to define as well, right? What will be the level? Level will be logging.info. Okay, so ESC time, so that's correct, completely fine. It is that. Let me cross verify this thing. Percent ASC time as, and then percent name as will be there, and then percent and level name will be there, and then message as will be there. Yeah, that's fine. So this is our own custom log. Okay, whenever the log will get generated, there will be a folder, will first a log folder will get created, and inside that with your current timestamp a log file will get generated, and the message will be printed in this particular format. First date will be there, then name will be there, then level name will be there, and then the message will be there. So that's all for this video. Hello everyone, welcome back. So as we have started explaining about the pipeline creation, and we have already discussed about the custom exception and logger. And so in this particular video we will be discussing about the some of the utils, okay, that will be common for the complete project. So we will be creating some of the main utils files, okay, and inside this utils folder, and that we are going to use throughout the project. So what we need to do first, inside utils we are creating a new Python file. Okay, so the Python file name will be main_utils. That will be the main utils that we are going to talk. So let me write it. So main utils, we'll add it to the git later on by using command prompt. So right now we'll keep it as it is. So what all things we are going to write inside this main.utils. So first thing is that we need to save object. Let's suppose when we will be working with the data transformation part. Okay, so there will be a when we are working with the data transformation part, there we need to convert our transform data into pickle format, or there we will be creating different kind of objects of data. Like let's suppose you are having a train data, and that is stored inside a object right now. Now we need to save that particular object. So how we can save that particular object? By using this save object function. Okay, so this is the save object function. I'll explain it, but before that I need to write some of the import statements. Like OS we are going to use here, even though we will be using import sys and then import DLL, that is also required. We'll explain you what are imports is necessary. One by one we'll explain. YAML file is also important. YAML, also base 64 converter, that's also required. We have to somehow, like when we are taking the image from UI part or maybe the FastAPI, then we need to convert that image into some different format, right? So for that we need this base 64. And also, as we have already imported our implemented our this custom exception, so now we can import it from src, like this src, inside that logger folder is there, and then we are importing the logging, and logging is what, this logging we are importing from here. Okay, and same thing we will do for our exception as well, like from src dot exception import custom exception, that we have already written. Right, now I'll delete the unwanted. So this is the save object function. So you can see that enter the save object method, so that will be the log whenever we are going to use this save object function. So the first thing that will be happen, so in the log, inside the log, it will be written, like the message will be enter the save object method of utils, this utils file. So what we are going to do, whenever we have to will call the save object, so it will create a directory. Okay, and inside that particular directory it will save that particular object. Okay, and for that only we are using this dill library, and it will save our save our object in a pickle format. Okay, so same thing will happen, like we have already saved the object. Okay, now we need to load that object as well in maybe in different pipeline, maybe in different component when we'll be talking. Okay, so same thing we have to write for the load as well, load object. So same thing we are doing, we are taking the file path where exactly that pickle file is present, and we are loading it inside our object, and we are returning that particular object. So that's the save and load object. Okay, and after that one more function we will be using, that is image to base 64 converter. Okay, when we will loading the image from the API, fast API, so we need to convert that image into base 64 format as well. So image will come here, and then it will be get converted by using this base 64 library, is having a function b64 encode, and that will encode that will return a string only. Okay, and that will be base 64. We will be testing it when we'll go for the prediction part. Okay, and after that one more main function is important, main utils, you can say that. This is YAML file. So in this particular project we are going to use YAML file as well. Inside that YAML file, different kind of configurations will be mentioned there. So we need to load that YAML file in each of our components. So writing the same thing in each and every component, it is better if we can write it in the utils, and we'll use simply that, call that particular function and use it in different pipelines. It's nothing it will do, it will just open that file path wherever that YAML file will be there, it will load it and return it, nothing else it will do. So that's all the main util, or you can say the common utils that we are going to use in our entire project. Hello everyone, welcome back. So in this particular video we will be starting our pipeline creation, and we'll start from the data ingestion part. So let me open PyCharm and then we'll start coding. Okay, fine. So as we have already created our utils, like main utils file in our previous video, or also we have created our custom logs and exceptions. So now come to the components part. Okay, there we will be required a data ingestion file. So what we will do, we'll create a data ingestion file inside that, and that will be a Python file. So we have to just write the name here. The file name will be data underscore ingestion .py. So we will be writing code everything here. Okay, and it is asking us to add to GitHub. We'll add it by using git terminal. Okay, so as of now I'm just canceling this thing. Okay, So data ingestion. So what we are going to do in this data ingestion pipeline, so we are going to take the data from the Google Cloud server, or you can say the Google Cloud storage we are going to take. So in this one, we will be using the GCP. So you should be having a GCP account. Okay, so let me open GCP first. Let me show you how you can create a storage there. Then we will be able to extract data from there. So let me open it. Just give me a sec. Okay, so once you will log into your GCP current account, then you will be able to find this kind of a UI, and then you need to write here the storage. Okay, then this cloud storage will come here. So if you will open it, then you will be able to see you have to it's a bucket. So there are these many buckets are there. So what you need to do, you have to create a new bucket for that. So I'll just create a new bucket. So our project name is signature recognition. So I have written sign dot recognized. Okay, and I'll click on continue. Then I'll select the region as well. Region wise, it will be multi-region, and that will be related to Asia. So I have selected that. You can select based on that. If you are belongs to the US region, then you have to select this one, European for this one, Asia for this one. Okay, so I have selected this one, Asia, and then I'll click on create one. Okay, so this will be the bucket, and from here we will be fetching the data. So as of now, what we are doing, okay, we will be I'm just uploading the file here. Okay, just give me a second. I'll upload the zip file that we are going to fetch it by you in data ingestion file. So just give me a second. I'll upload it. Okay, so we need to upload that dataset file here. So we'll just click on upload file here, and this is our dataset. So I'll just click on that and open. So within few minutes, it will get uploaded to this particular bucket. So meanwhile, I'll pause the video. Once the upload will be done, then again we'll resume. Okay, so as you can see, the data set is uploaded here. Okay, this one is the data set. This is the zip file, and this data set we are going to fetch by using this data ingestion file. Okay, so we will be writing code here right now. So before that, I'm importing few of the libraries that is required for this particular pipeline. So OS is required, and also import sys, and also as we are going to import the zip file, right, like we are going to load the zip file from the GCP. So we need a zip file as well, library zip file, and from there we will be importing zip file. Okay, and also we will be maintaining the log as well. So from src.logger import logging, that will also we need to import the exceptions that we have already built in our previous lectures. Okay, so these many things we have imported. Now before writing code for the ingestion pipeline, we need to configure, okay, we need to configure our Google Cloud server. Okay, so there is a configuration folder. It is there, it's present there. So what we have to do, we have to write a code to fetch the data from G-Cloud. So and for that we need to connect our Python code to G-Cloud, right? So it's a kind of a syncing operation that we are going to perform here. So we will be writing a Google Cloud syncer here in this config file. So what we are going to do, we are just going to create a new Python file here inside configuration, and the file name will be G-Cloud syncer. We will be syncing the data set from Google Cloud. So the file name is Google Cloud syncer. It is. So we will be adding it on GitHub later on. Okay. Now in this one, we are going to import some of the libraries like OS and 6. So these are pretty common libraries. Everywhere we are going to use it. Also we will be writing the exception, importing the exceptions as well, importing custom exception. Now what we'll do, we'll create a class with the name of gcloudsync. Okay, and inside that we will be writing two functions there. So the two functions will be one, sync file to Google Cloud. Like we need, when we want to push our files to Google Cloud, we need a function called sync file to Google Cloud. And whenever we want to sync something from Google Cloud, so we will be requiring a function sync file from Google Cloud. Okay, so one by one I will be writing this function. Okay, so let me write it here, then I'll explain. So this is the function, if you can see, sync file from Google Cloud. So what it will take, it will it is asking for the GCP bucket URL, file name and destination. So from bucket, which file exactly you want to fetch, and what will be the destination, where exactly you want to store it. Okay, so there are two ways to do that. One command is from Google Cloud and one command is from gsutil, by using that. So what this gsutil will do, it will copy the file name from the bucket and it will keep it in the destination. Whatever location we will be provided, there the file will be kept. So we will be calling that function whenever we will be required, and that we are going to use in the data ingestion itself. Another function that we are going to use, that is sync file to Google Cloud. Let's when we will go with the pipeline, like a model pusher pipeline, there we need to push our model to Google Cloud, right? So at that point of a time we will be using this sync file to Google Cloud. Here also we will be requiring two parameters. First is GCP bucket URL, second is file path. These two things were required there. So gsutil, CP is for copy. From file path we need to provide which file we want to push it to the Google Cloud, and the bucket URL, where exactly we want to push it, nothing else. So that's all about the Google Cloud Syncer. Now we will go with the data ingestion part. Okay, so what we require in this ingestion pipeline, we will be requiring the ingestion. In the ingestion, we need Google Cloud Syncer as well. So what we will be doing, we will be importing that particular thing. So Google Cloud Sync from src.configuration.gcloudsyncer, we are importing the class name gcloudsync. Okay, this class we are importing. Now I will create a class with the name of data ingestion. We have created this class. The spelling is mistake. Let me correct it. Data ingestion. Inside that we'll create a init function first, and init will take few parameters, and that parameter will be data ingestion config. Okay, some of the configuration we will be requiring, like what will be the bucket name, and what will be the file name, and where exactly we want to store it. So that will be stored inside data ingestion config. Data ingestion, that we will be getting from the data ingestion config. But till now we haven't defined where exactly we are storing it. Like in data ingestion config I am telling it, right? But we haven't created the ingestion component till now, like the this config entity till now. So there is a folder, you can see here entity is there. So inside that entity we are going to create two files. One will be the config entity. Inside that we will be keeping all our config related to the pipeline, and second will be the artifact entity, like what will be the what kind of output we are getting from that particular pipeline. That output we will be storing in the artifact, right? So that we need to write it inside artifact entity. So what we will do, we'll create two files here. First will be config entity. Okay, this is config entity. Another file that we are going to create, that is artifact entity. These two files will be required. Okay, so in config entity, we need to mention what all configuration we are going to use with respect to data ingestion pipeline. Okay, so what we need, we have to write few import statements as well. So as we are going to use here data class, so data class, from data class we are importing the data class. And also in our previous video we have created some of the common utils, right? So one of the utils that we are going to use here, that will be our main utils. Okay, and inside main utils we are using, like we are having read YAML file. Okay, so we have to read YAML file as well. Okay, and till now we haven't defined where exactly our YAML file is. So what I'll do, we'll create a new folder, config folder, and inside that config folder we'll be keeping all the YAML files that will be required for this particular project. So I have created the config here, and inside that config I'm just creating one new YAML file. So I'll just create a file with the name of config only, and the extension will be .yaml. Okay, fine. So in this config.yaml we will be writing our zip file name and the bucket name. What is the bucket name and what is the zip file name that we are going to fetch it? So it's a data ingestion that we are going to do. So it's a data ingestion config, and from that we are going to use zip file name. So I'm writing zip file name, and that zip file name is dataset.zip. Okay, and bucket name, we have to mention there. The bucket name that we are using is sig underscore, sorry, dash RECOG. So I'll write the bucket name as well. Okay, that's for the data ingestion file. So we have created this YAML, and this YAML will be read it by this read YAML function. Okay, so now we'll go to the config entity. What we need to write inside this config entity. So we'll just create the data class here. Okay, and whatever things will be required, I'm writing it, and then I'll explain it. We have created the data. So the data ingestion config class we are creating, and we are reading the config from read YAML file. We need this parameter config path. So from where we will get this config path? So that we are storing inside our constant, because this will be same for complete pipeline. So what we are defining, we have created a folder with the name of constant, and inside that constant itself we will be creating some of the things that will be required for complete project, complete pipeline, you can say. So some common constants are there, so that I'm just going to write it here. So I have imported OS here and imported torch as well as date time. Torch just to check whether the, like, in our system CUDA is available or not. So we'll use for this use CUDA and device. Okay, and this is the config path. So what is the config path? os.get current working directory. So it will go to this current working directory signature recognition. Then inside that config folder will be there, and then inside that config file is there, right? And also we are creating a current timestamp. Okay, just to create a artifact directory. Okay, whenever artifact will be generated, so it will be stored with a current timestamp, so that it will be easy for us to track down, right? So now you can see we have mentioned this thing in our constant, so we need to import as well. from the constant. So what I'll do right now, so I'll simply import everything from the constant here. So from src.constants import star. So if I'll mention star here, so that means everything will get imported from the constant component. So now you can see in this config file path, this config is there. Right now we are able to read this config file, and also we are able to get the bucket name from config, this config.yaml file. We have created this data ingestion, and inside that this bucket name is there. Okay, so that will be our bucket name, and for zip file same we have done that, this dataset.zip. Okay, now what we are doing, okay, when we will run our data ingestion component, right, so we will be fetching the data from Google Cloud Storage, and then we have to store it somewhere locally in our system, and for that artifact directory should be there. So we are creating a data ingestion artifact directory where we will be storing that data set.zip file. Okay, so this data ingestion artifact directory we haven't mentioned in our constant till now, so we need to mention that as well. So let me mention, so I'll write it here. It's related to whatever constant will be related to data ingestion that we are going to write after that. Okay, so everything will be there. So data ingestion artifact directory, so it will create a directory with the name of data ingestion artifact, and inside that all the artifacts related to data ingestion will be kept. Okay, and this is for zip file path. Now the configuration we have built for the data ingestion pipeline. Now we need to use this thing in data ingestion component. Okay, so again we need to import it as well, right? So from src.entity.config entity we are going to import data ingestion config. Okay, and that we are going to pass it here, it's data ingestion config. Fine. Now we'll write some of the statement for that, like parameters. What it is doing, it is taking the parameter data ingestion config. And what is this data ingestion config? It contains the configuration of data ingestion pipeline. Okay, now we will be defining that as well. So we'll be calling that data ingestion config. Simply I'll copy it from here, and then this one. Also this is the class that we have imported, so we need to define it in that as well. So we'll just write here gcloud equal to gcloud sync. So gcloud sync will be there. Fine, so that's enough for this init file till now. Now we'll create one function that will get the data from gcloud and store it inside in a artifact folder. Okay, so I'll just write that particular function and then I'll explain it. Okay, so this is the function that we are going to use. The function name is get data from gcloud. What this function will do, this function fetch the data from gcloud, and what it will return, it will return the data into data ingestion artifact. And if on failure, if we are not able to, let's suppose if that dataset.zip file won't be present in that particular bucket, it will write an exception log and then raise an exception. So whatever exception will be there, it will be present in the logs, as well as it will raise a exception as well in the terminal. Okay, when you will run this one. So what we are doing inside that, first we are logging the message that we have entered into this particular function, and this function belongs to the data ingestion class. Right, now we are making a directory. Okay, here we will be making a directory with the name of artifact, and inside that artifact with new timestamp a folder will get created, and inside that data ingestion artifact folder will be present. We will be seeing that structure once we will run this particular pipeline. Just wait for that, we will be there. Now what we are doing, we are using this gcloud sync class, and from there we will be using this sync file from gcloud, and it takes 3 parameters from, if you can check it, bucket URL, file name, and destination. So the bucket URL name, bucket name, data ingestion config dot bucket name that we have defined here. This is the bucket name, data ingestion config inside that. Now also we need the file name, zip file name is there. So that also we have mentioned in our config entity, zip file name. And where we want to store it, data ingestion artifact directory. That is also we have mentioned there, data ingestion artifact directory. Okay, so once this function will get run, so it will take the data from gcloud and keep it inside the data ingestion artifact. Now we got the zip file. Now what we need to do, we need to unzip that file as well, right? For that we have to write a function. So I'm just going to write that particular function. So the function name is unzip and clean. Okay, so what we are doing here, unzip and clean, this function will unzip the data and return the unzipped data. It will unzip the file, that zip file, and inside that 2 folders will be there. One will be with the forge name and second one will be the original. Okay, so what we are doing, we are using this zip file library that we have imported above, and we are taking the path of zip file, that is we have already mentioned there, zip file path, wherever we are the file that we are stored inside the data ingestion file. Okay, and it will extract it in that particular location itself, in the data ingestion artifact only. It will extract it and keep it that file. Okay, and if it fails, it will log exception and raise exception as well. Now the thing is that how we will execute these functions. So for executing this function, we have to write a data ingestion component, initiate data ingestion function as well. So I'll write it that and then I'll explain you. Okay, give me a sec. Okay, so you can see data ingestion function we have created, and what output it will generate, it will generate the data ingestion artifact. But till now in the artifact entity we haven't mentioned what kind of output will be generated by the data ingestion file, right? So we have to write it as well. So what we are doing here, we have so in data ingestion what we are going to do, we are taking fetching the data from Google Cloud. We have to unzip that folder, okay, and unzip that file, zip file, and then we will be passing that folder path to the next pipeline. Okay, so what will be the artifact? So artifact will be the dataset path. Okay, so I'll just write it here in the artifact entity, what we are going to generate from the data ingestion artifact. So we will be importing the data class, and from there that data class, and now whatever artifacts will be generated, that will be generated from model ingestion. You can say that data ingestion artifacts will be generated, and that we are going to mention it here. Now at the rate data class we need to mention, and then we'll create a class with the name of data ingestion artifacts. Okay, and inside that we need to write it here, dataset path that we are going to generate, and that we have to provide to next pipeline. Okay, that's the thing we have to do. And one more thing that we need to do, we have to define dictionary. We have to convert it into dictionary as well. Why we are converting it into dictionary, that we will be explaining later on when we'll talk about the Airflow. Okay, so as of now, whatever output will be there, right, whatever output or artifacts will be get generated, their dictionary will be also get converted here. Okay, So that's in the artifact entity that we are going to generate from data ingestion pipeline. Now we need to import that as well, as just like the data ingestion config. We have to import from src entity dot artifact from data ingestion artifacts. We have to import it. It's the data ingestion, so we have imported it. Fine. So what this method will do, it will initiate the data ingestion, and this function initiate data ingestion that we have done, and it will return the data ingestion artifact. That's what we are returning it. And also on failure, it will write an exception log and then raise an exception. Now inside this data, inside this ingestion data initiate data ingestion function, we will be writing the flow of our function, how this function will work, like when we are going to call this one and when we are going to call this one, right? So that we are going to mention in here. So we are writing a log statement here. Log statement is there. So first thing that we are going to call, we are going to get the data from gcloud. Okay, and that data will be stored inside the artifact. When we'll run it, we'll show you that as well. And then after that, we'll unzip it. Okay, then after that, what we are doing, we are removing this datasort.zip as well. Okay, we don't need that. Once we unzip that file, right? So we got the two folders that will be original and false, so we don't require that dataset.zip file. Okay, because, and so after that, once we got that folder, okay, that original and false, so we need to give the root file directory as well, like root dataset directory. So where exactly these two folders were present, right? So these two folders were present inside the data ingestion artifact. So that data ingestion artifact, we are returning it here. Okay, now we need to run this data ingestion, right? So just to run this one, we are going to create inside pipeline, there will be a file called training. Okay, that we are going to create it. So training.py, because this is a part of training. Okay, so whatever things we will be writing here, so that will get executed by using this training.py file. Okay, so I'm just creating this training.py file. Now same thing, some of the import statement we need to do. Common imports will be this one. Okay, and also we need to import the data ingestion. So till now we have worked till data ingestion part, so we have to import the data ingestion. Like this data ingestion component should be run by using this training, right? Now what we need to do, we are going to create a class with the name of training pipeline. So whenever we'll run the training pipeline, first it will go for the data ingestion pipeline. Okay, and we'll define the init as well. Okay, and inside that we will be calling the data ingestion config. So data ingestion config also is required, so we will be importing that as well from src entity dot config, and we will be importing data ingestion config, right? So data ingestion config we are using, and we have to give it inside a variable name called the data ingestion config will be there. Okay, that is, now we are going to write a function called start data ingestion. So we will be writing a function, just this function will start our data ingestion part. So even though we need to import the data ingestion artifact, so I will just write it here, src dot entity dot artifact entity data ingestion artifact. So what we are doing inside this start data ingestion, so first the logging we are doing. Okay, so once this function will call, so it will go to the data ingestion file, this file. Okay, and in this file, it will go to the initiate data ingestion. Okay, in this one you can see that data ingestion dot initiate data ingestion that we are calling. Okay, and it will give us the output in the artifact, right? It will generate some artifact, that artifact will be stored here, right? Now just to run this start data ingestion, we need to write inside run pipeline. So we need to run the pipeline as well, this training pipeline. So what we are going to do here, so we will be writing a function to run this particular pipeline. So run pipeline is a function, and except statement also we need to write exception as e. Then we will be generated our custom exception is custom exception. It will be instances from e. Okay, fine. So this is the data. So now we are ready for the data ingestion. Okay, once we will run this training.py file, then our data ingestion will start. Okay, and to run this file, we need a separate file, or we can say that a demo file is required to run this one. So inside this main.py itself, I'll write this thing. I'll delete everything, and whatever things required to run this pipeline, that I'm writing. So what I'm writing, I just want to run this training pipeline. This I'll go to the train and I'll run this training pipeline. So I need to call this run pipeline. So what I have written here in the main.py, so I'm just running this run.pipeline part here. So we are completed this data ingestion till now. So now what we need to do, we need to save all the files first. Okay, and now we will be running this main.py. So what you will be able to see, like we are able to fetch the data from Google Cloud, and we will be able to store it inside the artifact. I'll just run it in front of you, and then you will be able to see it. It will take few minutes. So you can see here now the file is getting download. Okay, it's copying from this this particular bucket, and the file name is dataset.zip. Operation got completed. Now if I'll reload it, you can see earlier artifact folder was not there, right? So once we will expand it, so you can see inside artifact there is a folder got created with the current timestamp, and inside that data ingestion folder is there, and then this two folders are there, original and forged, and that dataset.zip file got deleted because we have written here code for that, right? os.remove wherever that particular zip file. So what we are writing, deleting dataset.zip file. So everything will be stored in the log as well. So you can see in the log, this log got generated. So once you will click here, so you can see in the log as well, we have entered to the run pipeline method of the training pipeline and exited with the data ingestion method. And artifact that where we are storing, that is stored in this particular location, you can see. So everything is logged here. So we can see that we can say that like our data ingestion component got completed. And that's all for this particular video. We'll try to go for the next pipeline in the next video, and the pipeline will be data transformation. Hello everyone, welcome back. So in our previous video, we have already discussed about the data ingestion pipeline. So in this particular video, we will be discussing about the data transformation pipeline. So again, what we need to do, we will be creating a new Python file inside our components. So let me create it. I'll click on new and then Python file, and this one, this stage name is, the pipeline name is data transformation .py. We'll add it to the GitHub through command. Okay, fine. So what all things we need to write inside this data transformation pipeline? So first thing is that what we will do in our data ingestion pipeline, we have already saved our artifacts, and that is the data set, okay, that we have already saved. So what we need to do, we need to take those data set and we need to transform those data, right? So what kind of a transformation that we are going to provide, that we will be discussing in this particular video. So let's start coding. So we will be required some of the libraries to do these things. Okay, so most common things are this one, import os and import sys, and also we will be requiring this torch library. Okay, and also we need to import the logs, our custom log, src.logger import logging. Okay, and also we will be importing this one, the exception, custom exception that we have made till. So exception, import custom exception. Okay, fine. So as we are going to deal here with respect to the data set, so we have to import the libraries. One data set library is there, and that is present inside Torch Vision. Okay, so from Torch Vision we are going to load import data sets, and the transformation we need to perform. So there is a different library present inside the Torch Vision, so that will be transform, and we are keeping it as a alias t. So whenever we will be calling this transform, so we just need to mention t there. Okay, fine. And also if you can so we will be using the save object as well. You can, you know that like when we have created our common utils, or you can say that main utils, at that point of a time we have created few functions like save object or load object. So this kind of functions we have created. So in this particular transformation pipeline we will be using one function called save object. So I'm just importing that, so it's present inside src.utils, the main utils, import save object. So now you can see that these things are coming working as a library now. Okay, so that is the use of, that's just because of this setup.py file. This complete src folder is working as a library. Okay, okay, now so what I'll do, I'll create a class with the name of data transformation. Okay, the spelling is wrong, correct it. Okay, and inside init we will be defining the things that is required. So we need data transformation config as well. So the configuration related to data transformation that we required, so we need to create that as well. So we will be creating, just give me some time, I'll just create it. So what we need to do, we have to create data transformation config, and that will be written inside this entity. Config entity is there. Okay, so inside that we will be creating one more data class, and inside that data class we will be writing all the things that is required related to data transformation, all the configurations related to data transformation. So first thing is that that will be common, that's like read this YAML file. So this will be common. So what I'll do, I'll just simply create the class first. Class name will be data transformation config. Formation, make sure you won't do any kind of a spelling mistake there while writing, else it will again give you error. Okay, fine. Now first thing is that we will be requiring this config to read our YAML file, and inside the YAML file also we need to write some of the configuration, so that I'll discuss. Okay, so this is about the transformation config, and what are configuration that we are going to use it, I'll just write it here and then I'll explain you what all things are required. Okay, so you can see this one, this std is required. Okay, mean, standard deviation, mean, image size, degree, negative, degree positive, train ratio, valid ratio. So these all kind of a configuration we will be using in our data transformation pipeline. Okay, and you can see these are the red marks. So because these data are taking we are going to take this information from the constant, and inside our constant we haven't defined the data transformation artifact directory name. So that also I need to mention it here. So what I'll do, I'll just open there. So as I have opened there, and I'm just going to write it, what all things required for data transformation. So these are the data transformation constants. So this is nothing, we will be creating a folder with the name of data transformation artifacts, as like in artifact folder data ingestion artifact got created. So just like that, one more folder will get created with the name of data transformation artifact, and inside that whatever transformation we will perform on the data, okay, and then we will split that data, right? So that transformed data we will be saving in pickle format, right? So that file name will be this, okay, and that file will be present inside the data transformation artifact. When we'll run the code, you will be able to see all the things, okay. So right now I'm just defining it here. So these are for the transformation, and these all configurations are related to the transformation, and this one is to create the artifact directory, data transformation artifact directory, and this one is to create the train transform object file path, like when we will transform our data, when after the splitting the data, so we need to save it somewhere, right? So we'll save it in some kind of a object, and that object we need to save it in a pickle format, right? So that is the path of that object file, okay. So that's the path I have mentioned that we are going to use in this transformation. Along with that, some of the configuration we will be requiring in this read YAML file as well, like this config as well. And why we are maintaining these many configuration in different where, so that's the reason for that, so that I'm telling you right now. Let me write it, then I'll explain you why we are using these three kind of configuration. Somewhere we are writing the constant, somewhere we are writing the configs related to data ingestion pipeline, something I'm writing in the YAML file. Why I'm writing this? So if you can see in this config.yaml file, so these are the values that we can change it, okay. Like let's suppose when when we will deploy this particular project on any kind of a cloud services, and in between that we need to test it, like uh, we need to change few parameter, and then we need to test it, like whether on that particular parameter how our model is behaving, right? So if we'll write everything inside our constant, so this constant, you can say that it is a part of this src, or you can say that this constant, or this artifact or config entity is a part of this src, or you can say that the complete library part, complete pipeline part, okay. So let's suppose if we need to do any kind of a changes here, so we need to do changes in our entire pipeline code, right? So just to avoid this thing, we are creating a separate config file as well, just to do the changes. Like if we have to do some minor changes, right, so we will do it in this config file only, and we don't need to do any changes in our pipeline, and it will get deployed once again without creating any kind of a issue. Okay, so that's the use of that. So it's very useful whenever we are going for this kind of approach. So it's better we have to write this kind of a YAML file, okay. So that's just for a future purpose. We can write this thing in our constant as well. There is no issue with that, but for the simplicity, I'll keeping it in the config file. So if once our model is deployed somewhere, if we want to do certain changes there, then we can do the changes in config only, and we can test it how the model is behaving. So that is the difference in that is the reason why I'm taking these many configuration details, okay. So now come to the data transformation. So as we have already created this data transformation config in config entity, so we need to import as well. So we will be importing that, import src dot entity dot config entity import data transformation config. Now we will be writing that data transformation config. And also one more thing that we need to import related to artifact, because the data that we are going to use it in this particular pipeline, and that data is coming from the data ingestion artifact, right? So the artifact that we have generated in the data ingestion pipeline, from that, so we need data ingestion artifacts as well, right? So we will be writing that as well here. So that will be data ingestion artifacts, I'll write it there, data ingestion artifacts. So these things we have done. Okay, now I'll write here some kind of a doc string. So what we are doing in this one, what all parameters we have taken. So I'll write it in the doc string. So let me write that about the data ingestion artifact as well, what we are going to do with the data ingestion artifact. So data transformation config that we are using, that is configuration for data transformation is pipeline, and data ingestion artifact is where we have stored our artifacts with respect to data ingestion pipeline. Okay, now we will be requiring something, so we need to call this thing as well. So we'll write this, I'll write it simply same thing we have done in the data ingestion as well. Data ingestion artifact is there. Okay, and also whatever things that I have mentioned in this config entity, this one, right, these things also we have to mention here, right? So I'll just write it, wherever we need to use it, I'll simply call self.std or self.mean, and we will be using this thing. Okay, now come to the transformation function that we need to create. Okay, so let me write it and then I'll explain you what exactly this function is doing here. So if you can see this get transform data, so it's very simple. It is not taking any kind of a parameters. It will simply return you the transform data, nothing else. So what it will do, it will go whenever the data will be passed through this transform get transform function. Okay, so what will happen, it will resize it. Okay, so and so what will be the size of the image, so that we have already defined it here inside this part image, and it is taking from this config.yaml. You can see that image size will be 224. Okay, and this is the image size, and this is the degree. So negative, what will be the negative degree and what will be the positive degree that we have defined in the YAML file, this one that we are writing here. And after that we are converting it into the tensor, then we are normalizing it. So what will be the mean and what will be the standard deviation that we have already defined in the config.yaml file. That's the thing. So the thing is that what we are doing, we have created a function with the name of get transform data. What it will do, it will transform our data, nothing else it will do. And in transformation, what it will do, it will resize it, it will do some random rotations, it will convert it into tensors, and as well as it will normalize it. These 4 tasks it will perform. Okay, and once this transformation is done, then what we are going to do, we will be splitting our data. So as of now, the data we are having, that's the complete data we are having. Okay, we haven't split it inside into train, test, or split, sorry, yeah, train, test, and valid, right? So we will be splitting our data here, right? So what we are doing, we are creating a function split data, and it is taking 2 parameters. First is the data set, okay, and the total count, okay, that we need to define. So how many number of data set we are having right now, okay, total number of records, or you can say that total number of images that we are having right now. Okay, so what we are doing, simply we are just writing it, integer is there, whatever value will come, that will be an integer form. So total count is there, and the train ratio that we have defined. So what is the train ratio? You can see that train ratio is 0.6. So we are taking 60% of data for training, for validation 30%, and rest of the amount will be go for the testing. So we are using this torch.utils.data.random split, and it will take the parameter dataset, and also we need to define it like how many splits we want to do it. Okay, so it's 60%, 30%, and 10%. So these 3 so we have splitted the data, and now we are returning the data. Okay, now the data will be train, valid, and test. So these are the data that we have splitted. Now we need to define a main function, or you can call it the init function, initiate function. So that will initiate all the things that we have written till now. Okay, we have created a function for transformation, we have created a function for splitting, but we need to call that function as well, right? So that's what we have to do. So you can see that we have created a function with the name of initiate data transformation, and what it is doing, it will return you the data transformation artifact. So till now we haven't defined inside our artifact entity this one what all output we are looking from this data transformation artifact. So let me define it, like what kind of output we will be getting from this data transformation artifact. So let me write it here. Give us some space. Okay, so you can see that from data transformation artifact, what we are going to generate, we will be generating four things. Okay, first is that train transformed object. So the train transform data that will be stored in the pickle format. Okay, that their path we will be storing here. Okay, so and all the things are in the string format, so it's a path. And the last one that we are storing, that is class. Okay, so now number of classes, how many number of classes we are having in our data set, that also we are passing to the next pipeline. We have to pass it to the next pipeline, so we are keeping it inside the data transformation artifact. So as we have defined here the data transformation artifact data class, now what we need to do, we need to import as well. Okay, so it will be inside this data is entity dot artifact entity, so data transformation artifact. So now you can see there was red mark earlier, now it gone because we have defined it, we have imported it. Okay, now we need to we have just entered, so we are using this logging just to log everything. Okay, what we are doing, we are taking the data. Okay, data set we have imported from the torch vision library. Inside that image folder function is there, that is taking the path of the image from the data ingestion pipeline. What we have done, we have saved the path, like we have provided the data ingestion artifact folder path here. Okay, and also we have provided that get transform data function as well. So what this complete thing will return, it will return the data set, a complete transform data set it will return. Okay, then data set will be returned. Then what we need to do, we need to find the total number of count as it is required for the splitting the data. So we are just calculating the total number of count. Now once the total number of count is done, then also we are trying to find out the number of classes, that also we need to pass in our data transformation artifact. Now we are splitting the data, so simply calling the split data function as you have mentioned here, right? It is taking two parameters, data and total count. So data set we have already having this one, this transform data. Okay, that we have passing here, and total number, total count is there. So it will split our data into three part: train, valid and test. Now what we need to do, we need to save this transform data in some kind of a format, right? So what we are doing, we have already created a function with the name of save object. So what it will do, it will save this train data and valid data in a pickle format, right? So we have to just call that function, and we need to pass the object and where exactly we want to store it, the path. Okay, so this path we have already defined in the config entity. You can see that data transformation object file path, valid transform object file path, test transform. So this file path we have already defined where we need to store this thing, and we have given it, then it got saved. When we'll get this thing will get executed, it will get saved. Now we need to prepare our artifacts, right? So what all things that we are going to pass to the next pipeline, so that we will be writing in that artifacts. Okay, so we will be passing these objects, right? These objects we need to pass to the next pipeline as well. So I have created inside this one as well artifact, so these things will be passed, and also the number of class we need to pass it. Okay, so that is the data transformation artifact. That's the data transformation pipeline that is going to do. Now we need to test it, whether the things that we have written, is it correct or not, or we are getting some kind of error while executing. Okay, so what we need to do, we need to write everything inside the train pipeline as well, because it is a part of training, right? So we need to write everything inside the training.py as well. Okay, so as we have already written for this data ingestion, so this data ingestion got executed once, we will run this one. Now we need to write something related to start data transformation as well. So I'll be writing here, and then I'll explain you what we need to what we have done there. Okay, so let me write it first. So I'll give some space there and then I'll write it. Okay, fine. So this data transformation artifact, so as I can see that we haven't imported this thing right now, so you can see there is an error, right? Okay, okay. Apart from that, other things that we need to import, we need to import the data transformation config as well. Okay, so that also we will be importing. So from, just like the data ingestion, we need to import the data transformation pipeline as well. So src.components, we will be importing data transformation, and from there data transformation we are calling it. Okay, and also we need to use the data transformation config, and that we will be calling here. So I'll just write here the data transformation config. Now I'll call it here. So it's data transformation config that we have done. Okay, okay, fine. Now you can see there is no error right now. Okay, so what we are doing in this start data transformation, it is taking two parameters. Okay, first is one parameter it will taking. Okay, that is data ingestion artifact. Okay, so whatever things coming from this start data ingestion, so it is returning the data ingestion artifact, and that data ingestion artifact will go inside the start data transformation. Okay, so what it will do, it will call for the data transformation class that we have imported here, right? Data transformation, call for that, and then inside that data ingestion artifact it is giving, and also we will be providing the data transformation config. As you can see, we are calling this particular function, and this particular function taking two arguments, expecting two arguments. One is the transformation data transformation config, another one is data ingestion artifact. Okay, so that's what we are doing here. We are passing here data ingestion artifact as well as the data transformation config. Now, okay, now we are calling the initiate data transformation function. Inside our data transformation.py, we have written here initiate data transformation. So we are calling this particular function. So once we call this function, it will give us it will return us data transformation artifact. So we are calling it and we are saving the data transformation artifact, and we are returning it as well, right? So what we need to do, we need to mention this thing in the run pipeline as well, right? So after this data ingestion, which pipeline will run, right? So the pipeline that will run, that will be data transformation data transformation start data transformation. So what it will do, it will take this data ingestion artifact as a parameter, and it will also store the artifact data ingestion transformation artifact. Now what I need to do, I'll have to simply run the project. Okay, and let me see, let's see like if we are getting any kind of issue or not. Okay, so till now we have learned like uh, last time when we have run this, so we have run till this data ingestion artifact. Now if I'll run it, so you will be able to see there will be one more folder will get created with the name of data transformation artifact. Let me run it. Okay, sorry, we need to run the file name main.py. Sorry, I'll run it. May take few time. Okay, now it is downloading the data from gcloud storage. Once it will download, okay, download is completed. Now the complete operation is completed. Now what we need to do, I'll just simply reload all from disk. Now you can see this one got generated here with the current timestamp. Now you can see two folders are there, data ingestion artifact and the data transformation artifact. So that means our data transformation artifact runs successfully, and you can see the pickle files, like the transform data is already saved here. Now, okay, so now we will be saving using this transformed artifact in our model trainer part. Okay, so that's all for this video. Hello everyone, welcome back. So in our previous video we have already discussed about the data transformation pipeline. So in this particular video we will be discussing about the model trainer pipeline. Okay, so let me open PyCharm and then we'll start the coding. Okay, fine. So what we need to do, we will be going inside this components and then we will be creating a new Python call with the name of model trainer. So let me create it, model underscore trainer. So this will be our Python file. Okay, and we will be adding it to Git through terminal, not through PyCharm. Okay. So whatever things that we have to perform, okay, we will be writing in this model underscore trainer .py file. So I'll be importing few of the libraries that is common for each and every pipeline. So import OS, import sys, and then also we will be requiring the torch. We are using PyTorch in our project, and for seeing the progress we will be needing this tqdm library. Okay, so from tqdm import tqdm. Okay, and also we will be requiring the torch neural network. So import torch.nn, that's nn. Okay, and models also we will be importing, so it is present inside the torch vision library, and inside that models is there. And also we will be importing the logger, so that the custom log that we have maintained, so we created that, we are going to write it. And one more thing that we are importing, that's the thing we haven't discussed till now, because that is the importance. It comes in the data, this one in this model trainer part only we will be discussing about that. So this device, why we are using this device, that I'll let you know in this particular video. And also torch.utils, some of the utils that is present inside the torch, that also requires. So torch.utils.data, and we will be importing the data loader. So as we have already discussed this thing like data loader in our Jupyter notebook part, so if you are not familiar or if you have missed those videos, so you can watch that. Okay, and we are importing our custom exception as well. Then load object is also required. So as in our last pipeline, in the data transformation pipeline, we have saved some of the things, right, in the data transformation artifacts, like the transform data, like train, valid, and test data we have saved into the pickles format, right? So that data we need to load it. And how we will be loading it? By using this function called load objects that we have created already. And also we will be importing something from src.config entity dot config. So model trainer config. So as of now you can see it's a red mark is there, because till now we haven't created this model trainer config. Okay, so what we will be doing, first I'll just create a class with the name of model trainer. Okay, keep it in capital letter, it will be in capital trainer. Okay, model trainer will be there, and then inside init we need to write everything. So it is taking two parameters. One will be the model trainer config, and second will be the data transformation artifacts. Okay, so whatever things we have stored in the previous pipelines, that also we will be requiring in this particular pipeline, in model trainer pipeline. So what I'll do, model underscore trainer underscore config, and then we will be calling the model trainer config. And also we need to import one more library, that more thing, that is from entity itself, artifact entity, data transformation artifact. So for that I need to mention here data transformation artifacts. I'll just call it data transformation artifact. Now first thing that I'll do, I'll create the config. Okay, I'll create the data class inside this config entity with the name of model trainer config, and then we'll proceed ahead. Okay, so first we'll create the config entity. So what all configuration that is required in the model trainer that we will be writing, I'll just write it and then explain you what all things are required and why these things are required. Fine, so keep some space. Okay, you can see that first thing that we have imported. Okay, we are using this read YAML file. Okay, we are just taking it, and also we will be requiring this LR is nothing but it's a learning rate. Epochs, how many epochs we want to train. Number of workers is nothing like how many cores of system, like how many cores that you want to use it for model training. Okay, batch size, you know that. So we need to create the model trainer artifact as well, folder. Inside this one you can see that just like this data transformation artifact is there, the same like that model trainer artifact will be there, and inside that trained model will be stored there, right? Model.pt will be stored there inside that particular folder. So these two things we will be defining inside our constant. So let me write the inside the constant as well. Fine, so you can see that model trainer artifact folder name we have defined, and the model that we are going to save it, that will be model.pt, and that will be stored just like that only. Okay, the model trainer folder will get created, and then inside that model.pt will be there. Okay, so that's about this one. And now we need to write something inside config.yaml as well. Couple of things we have mentioned there as well, so that we will be writing just like epochs and learning rate. So these things I have mentioned in this one. So epochs, so right now what I'll do here, I'll mention it till 5 epochs. Okay, and the learning rate will be 0.001, and the batch size will be 32, and the number of workers will be 4. I'll just keep it like that, or maybe I'll just what we can do for testing purpose, I'll keep it till 1 epochs. Okay, if I'll go for higher number of epochs, so it will take some time, and okay, and the video will be long, so I'll train it for 1 epoch only, just for testing. Okay, you guys can train whatever number of epoch you want to, you can train it. Okay, so now come focus on this model trainer. Now we'll write the docstring as well, the parameters that we are taking, and what all things, why these parameters are there. Model trainer config is there for config it inside that configuration for model trainer is mentioned there, and inside data transformation artifact, the artifact for data transformation is stored. Now we need to we need to define some of the things like config, model trainer config, no data transformation artifact. So these things we need to define. So you can see that model trainer config that we have defined it, data transformation also, and the learning rate, that whatever things that we have mentioned here, learning rate, epochs, number of workers, and batch size. So whatever things that we need to use it, I'll define it here. Okay, now we'll create some of the functions that will be required for this particular project. So we will be requiring only one function here, that will be train. Okay, so whenever we'll call this train function, the model will get our model will start training. Okay, so I'll write the function, then I'll explain it. Okay, so this is the train function. Okay, so I think I have already explained this thing in our Jupyter notebook discussion, but I'll explain once again. Okay, but in very much brief. Okay, so what we are doing in this train function, what we are taking parameter as a model, we are taking criterion, that is the loss. Okay, optimizer we are taking, train loader and valid loader. Okay, so we are training data set and validation data set that we are taking. Okay, and the first thing is that the train loss and test loss is 0 right now. Okay, once our model will start training, so it will increase or decrease depending upon the model training. Okay, so what we are doing, TQDM we are using just to check the progress, right? like that, and its training is happening. So what we are taking there, it is taking the data from the data trainer, and inside train data loader, and inside train data loader labels and images are there. So we are passing the images to the device, and device is what, like is if I'll show you, this is the device that we are using. So what we are doing here, torch.device CUDA. So let's suppose if in your system CUDA will be there, so this device will be CUDA. Okay, this one it will be. And if in your system CUDA won't be there, then your device will be CPU. Okay, so in PyTorch we need to define in that particular way whether your model is going to use CUDA or not. So we need to decide like that. Okay, if in your system it's CUDA will be there, or maybe NVIDIA GPU will be there, it will be utilized. Okay, so images will pass to that, and labels, even labels are getting passed, and then we are passing images to the model, and output is getting generated, and that output is passed to the loss function. So that loss will get created, like generated, and the loss, this item, we are taking this loss item and we are appending it inside that, appending for each epoch we are appending it, so that in once this complete epoch will done, then we will be able to get the total training loss and total validation loss. Okay, same thing we are doing for the validation as well. Image to device, labels to device, and then output we are passing, like image we are passing to output, and then the same output and the label will be passed to the loss function. It will calculate the loss and it will write it here, and this loss will be your validation loss. Okay, and how we are writing it, like how we will be able to calculate the exact loss or accuracy, train accuracy and test accuracy, by using this one. Okay, so whatever total train loss we will be having, that we will be dividing with the length of total transform data, train transform data, total training data. When we'll divide our total training loss with total number of records that we are having in our training data, we will be able to get the training accuracy. And for test accuracy, what we have to do, test loss, total test loss will be there, and we will be dividing it to the validation data, number of validation data, whatever we are having. Okay, and then we are just printing it. After each epoch, this train loss and test loss will get printed. This is loss, this is not accuracy. If I'll just change it, it's not accuracy, it's loss that we are calculating. So I'll just write it here as well, train loss and test loss. That's the loss that we are calculating, not the this one. Even though it's not a test loss, you can say that it's a valid loss, validation loss is that we are doing. Okay, so that's the thing we are doing here, nothing else. So that's the training part. Now we need to call this train as well, and before that we need to perform some of the things on our data as well. So we are writing a initiate model trainer function, and inside that we will be writing everything. Okay, we will be calling this train function and other before that also, and after that whatever things we need to perform with respect to model, okay, we will be writing inside that. So I'll just write it there. So now if you can see here, we are getting an error in this model trainer artifact, right? So because we haven't mentioned this thing inside our artifact entity. So what kind of artifact we are looking for from our model trainer So we are looking for only one artifact, that will be the train model path, and that train model path will pass through pass to our next pipeline, that will be model evaluation. Okay, so I'll just go to the model trainer, and also we need to import it, so it will be present inside this artifact entity. I'll just import it. Now the error is gone, if you can see here now. So what it will return, it will just return the model trainer artifact, and it will write an exception and raise the exception or log whenever it will fail. Okay, so what we are doing now. Okay, so first of all, from our previous pipeline data transformation, okay, as the artifact that we have stored, like trained artifact, like train transform data, okay, and the valid transform data that we have done. So we are loading it inside train dataset and valid dataset. Okay, And then after that, what we are doing, we are passing this data set to the data loader. Okay, and inside that data loader, what will happen, it will shuffle whatever the parameters we have defined here. According to that, it will perform some kind of operation on our data set, and then it will load it to the train loader. So what kind of a transform, like operations we are performing here, we are shuffling our data, and we are dividing into the batches as well, and the number of workers, it will be like how many cores that we are going to use for this train loader. Same thing we are doing for valid. Okay, that's thing. Now the model wise that we are going to use it here, ResNet 34, that's the model that we are going to use, and it is already present in the PyTorch library, as we have already imported here from Torch Vision, imported model. So it's a pre-trained model. Okay, if you want, you can read about it. Okay, the documentation is given there. So if you can see here, it's written there, the pre-trained weights used. Okay, is raised ResNet 34 below, and possible by default no pre-trained weights are used. So if I'll mention their weights, so that means I'm just going to use the pre-trained weights here. Okay, so you can read the documentation. Complete documentation is mentioned in this particular file. Okay, you can check it there. So we have loaded it inside the model. Okay, and after that, we are designing a neural network. Okay, because we need to change our last layer, right? So the ResNet model is trained on the 90 classes, but in our data set we are having only 2 classes, right? So we need to change the number of classes as well, right? So in the last layer we need to do some changes. So what we are doing, before last layer, we have just performing some dropout operation, and after that, in the last layer, I'm just mentioning the features, the number of features and the number of class. So the output, the number of classes that I have mentioned here, that is coming from the data transformation artifact, and that is 2. Okay, so that will be there. Now I'm just passing this model to device so that it can use the CUDA. Okay, because in my system CUDA is there, so that it is going to use. Okay, criterion wise, we are like the loss wise, we are using the cross entropy loss and optimizer SGD, stochastic gradient descent, that we are using here. And then we are going to start the training, model training. So it will start the training, so till the number of epochs, as we have mentioned here, only 1 epoch. So it will train for only 1 epoch, and once the model will be trained, so what we are doing, we are saving it. Okay, so where we are saving inside model trainer artifact folder. Okay, that will get generated here. Okay, and inside that we are saving the model with the name of model.pt. For saving that, we are using torch.save model object we are writing here, and the path that we are giving. Okay, and also we are passing that saved model part to our model trainer artifact. So that is about this model trainer pipeline. Now to execute this model trainer pipeline, we need to mention everything in the pipeline as well, the training pipeline, because it is a part of model training. So after data transformation, we will be doing the training, model training. So I'll just write it and then explain it, what we are doing here for model training. So it's for model training. So you can see that's model training artifact. So till now we haven't imported it, so we need to import it, the model trainer artifact. And also we need to import here model trainer as well from src dot components dot model trainer, then model trainer class we need to call it here. Again, same thing, we need to do it here as well, just like the data transformation and the data ingestion. We need to, for this model trainer config as well, and for that we need to write here model trainer config. Okay, same thing though. So we are done. Okay, now we are writing, we have written a function here, start model trainer, and it is taking a parameter called data transformation artifact. Okay, so this model trainer class, so this class we are calling. Okay, and this class is taking 2 parameters, model trainer config as well as the data transformation artifact. So these 2 parameters it is taking. So we are giving here data transformation artifact, from this particular, and model trainer config that we have already defined it here. Okay, and then what we are doing from this model trainer, we are calling the initiate model trainer. So this function we are calling, and it will be get executed when we are calling. And what this function is returning, it is returning the model trainer artifacts that we are storing inside the model trainer artifact. Now we need to mention this thing in our pipeline as well, run pipeline as well. So I'll just write it. So model trainer artifacts that we are going to generate. So I'll remove some extra space from here, and we will be starting the model trainer, and it is taking a one parameter data transformation artifact, and it will generate artifact model trainer artifact. So that's all in this training pipeline till now. So what we need to do now, we need to run our project just to check whether our model is getting trained or not. So I'll be writing here python main.py, and I'll hit enter. It will start executing. If I'll get some error, then we'll try to fix it. So as of now, it is running the data ingestion pipeline. It is loading the data from the Google Cloud storage. What we'll do, so you can see the model training got started. I'll pause the video for few minutes, okay, because it will stuck then. Okay, so as I have paused the video when it was starting training, as like if I didn't pause, so my system got stuck, so maybe because of that. So I have paused the video. So now if you can see that we have trained our model epoch 1, and I got this kind of a loss here, training loss and test loss. Okay, definitely we need to train more. Okay, so whenever we will be we have to do this change in this epochs part, so we'll simply go to this config.yaml and we'll write everything here like 10 110, and then it will be okay trained. Now we need to see we need to do what, reload all from this. So you can see this new folder got generated, model trainer artifact, and inside this model is saved model.pt. So we have successfully run till model training. So in our next video we will be discussing about the model evaluation part, how we will evaluate our model. Hello everyone, welcome back. So in our previous video we have discussed about the model trainer part. So in this particular video we will be discussing about the model evaluation pipeline. So let me open PyCharm and then we'll start the coding. Okay, fine. So if you can see here in components, we have worked till the model trainer.py. Now we need to create another Python file with the name of model evaluation. So let me create it. The file name will be model underscore evaluation .py. Sorry, there is a spelling mistake. This will be evaluation. Yeah, so model evaluation.py. I'm just going to create it. Okay, I'll cancel it, we'll add it later. Fine. So in model evaluation, what exactly we are going to do, there will be two models, okay, and we have to compare both of the models. So from where we will get the both like these two models. So first model is already present, like the model that we have trained in our previous video, the model is present here, and one model will be that is already present on the Google Cloud storage. Okay, so as of now we haven't pushed our model to Google Cloud storage. So whenever I'll run this pipeline, model evaluation pipeline, so there won't be any model coming from the Google Cloud storage for the first time whenever we will be training this particular model. But when we'll retrain our model, at that point of a time, what will happen for this model evaluation stage, another model will come from Google Cloud storage, and the model that we have trained currently, we will compare their loss. Okay, whosoever loss is decreasing, okay, that model will push to Google Cloud. Let's suppose the model that we have trained right now, currently that we have trained, if their loss is less than the model that we have, that model that is present on the Google Cloud storage, then we'll push our currently trained model to the Google Cloud storage. Okay, so that's the thing that we are going to do in this particular model evaluation part. So let me import few of the libraries. These are the very common one, OS and sys. Also we will be requiring the torch one because we need to load the model as well, and tqdm also we will be requiring to just to check the progress. It will be good. Okay. And also we will be importing device from this constant src.constants. We are importing device is nothing like, let's suppose if you are having a CUDA device, so inside this if in your system CUDA will be there, then in place of device CUDA will be present. If it is not, then CPU will be there. And also we need to import few utils packages from torch utils. So torch utils data, and we will be importing the data loader from there. Okay, and of course for evaluation we need data as well, right? And also we will be importing this exception, the custom exception that we have made, custom exception. Okay, fine. And other things also will be required, like load model is also there, because the model that we have trained, okay, or the object we have trained, right, the object that is present in the model transformation stage, right, that we need to load it. So for that also let me write all those things. src.utils.main utils import load object. Also we will be requiring this Google Cloud Syncer as well, as we need to fetch the model from Google Cloud Stories. So we will be requiring that, the Syncer, Cloud Sync. Okay, fine. Now we'll create a class with the name of model evaluation. Okay, now inside init we will be defining the parameters that it will take. So the parameters that it is going to take, that will be first the config, we will be passing there model evaluation config that we need to provide. So till now we haven't designed the model evaluation config in the config entity, we haven't defined there. So what I will do, first of all we'll define the model evaluation config in our config entity. Okay, so just like trainer we need to create that as well. So I'll just write it and then I'll explain it what all things required for this one. Okay, so model evaluation config. So first thing that we will be requiring this read YAML file, because some of the things will be present inside our YAML file, this inside this config.yaml file. What all things will be present, that I'll explain you right now. Just give me a second, some time. And the model name also we need to write what is the model name that we are going to. So this is present inside the init file, or you can say the constant. Okay, so that also we need to define it, the constants related to the model evaluation. So I'll just write it there. So these are the constant related to the model evaluation. Okay, so the model evaluation artifact is there. So what just like this model trainer artifact, there will be one more folder get created with the name of model evaluation artifact. And then best model, there will be another best model directory will get created, and inside that will keep the model. So best model will be whatever model that we are taking from Google Cloud Storage, that will be the best model. Okay, now we'll go with the config entity. So you can see that now this error went because we have declared this thing in our constant. Okay, fine. So after that what we are doing, we are taking the bucket name, and this bucket name will be mentioned in this config.yaml. So let me write the parameters that is required for this model evaluation config in this one as well. So for model evaluation config we need batch size, number of worker, and the bucket name, where exactly from where we want to push our things. Okay, so for that the bucket name that we are having, this one, this is the bucket name we are having. So we have to write sign recognize. So this is our bucket name. Okay, so these three parameters we are taking from this YAML file, we are reading from this YAML file. Apart from that, this is what we are doing, we are just creating a artifact directory, model evaluation artifact directory by this particular command. And inside this model evaluation artifact directory, we are creating one more directory with the name of best model. Okay, this is for that. Now the config inside config entity, we have already defined our model evaluation config. So now we need to import it as well. So from src dot entity dot config entity, we have to import model evaluation config. Okay, and that will present here model evaluation config. Okay, fine. And apart from that, we will be requiring model trainer artifact as well, so that also we need to import it. So first I'll import that thing, src dot entity dot artifacts, and that will be model trainer artifact. So I'll just write here, what is that, model underscore trainer underscore artifacts. Okay, and we'll define it model if artifact. And after that, one more thing will be requiring that data transformation artifact, because when we'll get the model, we need to perform some kind of operations there, like we need to test on the data set, right? And for that, the data that we are taking is from the data transformation artifact. Okay, so I'll just import that as well, data transformation artifact. So I'll just write it, data transformation artifacts will be there, and then I'll write it here, data transformation artifact. And also I'll write some doc string, like for all parameters this particular init function is taking. Okay, something is missing, I'll just write it that as well. Make the intent correct. Okay, so we are taking model evaluation, data transformation artifact, and model trainer artifact. These three things we are taking, and also we need to define it there inside that. So I'll just write it there so that we can use it in any functions that will be present inside this model evaluation class. Okay, so Google Cloud Syncer also we are using it. Okay, now we will be requiring few functions. Okay, so first functions that we are going to use here, that will be get model from Google Cloud. Okay, so first thing is that we need to do, we need to take the model from our Google Cloud storage. There is one thing is missing. Okay, we haven't imported the logger. Okay, so logging we haven't imported, so let me import that as well, because that is also important. So let me import. Now you can see the error is gone. Okay, so what this get best model from G Cloud will do, okay, it will just simply take the parameter like bucket name and the model name. Okay, it will go to the Google Cloud storage bucket. If you will when we will push it, okay, let me show you one example, like how it will take it. So let me open Google Cloud storage first. Okay, I'll go to this one, and the storage will select. Sorry, this is the wrong tab. Just give me a second. Okay, once again let me log in. It is asking for the password, so let me log in it. Okay, fine, and then Google Cloud Storage. So now you will get the bucket list. Okay, so sign recognition is there. So when we'll push the model, so there will be a model.pt file will be present there, just like this one. I'll show you that. This like this one. Okay, model dot. So what we are doing here, okay, we are asking for the bucket name, so the bucket name will be there. Then after that, the model name, the file name, you can consider it like which file exactly you want to fetch it from the Google Cloud Storage. So the model name that we want to fetch it, the model name, that is model.pt. Okay, and where exactly we want to store it? We want to store it inside our model evaluation folder, model evaluation artifact folder. There will be a folder with the name of best model, and inside that particular model will be kept. Okay, and after that, what we are doing, we are just returning the path of the best model. Okay, so wherever we have stored this, we stored our best model, so the path of that particular model, we are returning it through this particular function. Okay, fine. Now the next function that we are going to use it, evaluate. By using this function only, we will be able to evaluate our model. So what exactly we are doing in the evaluate? So this evaluate function is taking three parameters. Model we need to write, we need to give criterion, that is loss, because we need to calculate the loss, as well as we are providing here the test data. Okay, so that we will be calculating our loss on our this particular test data. Okay, so same thing that we have done for the training. Okay, same thing is there, but the only thing is that here we are not going to train for the model. We will be just passing our data to the model, and whatever loss it will generate, okay, and that loss we are just going to keep it, and will use that loss to compare. Okay, so instead of test accuracy, we'll write it test loss. That will be much better. Test loss and test loss, where we'll be doing that. So simple thing is there, the model, it is taking model loss function and test loader, and it is returning you the loss, the total loss on that particular data, that testing data. Okay, now we will be writing the initialize, like initiate model evaluation by function. So let me write it, and then I'll explain you one by one, like what we are doing inside that particular function. Okay, so now what we are doing in this initiate model evaluation function, we will be executing our this two functions one by one, and it will return us model evaluation artifact. And what we are going to return in the model evaluation artifact, that I will let you know just when I'll explain this particular function. So first thing what we are doing, we are loading the data set. Okay, so the load object function is there, and we are loading the data from the data transformation artifact, and that is the test data that we are loading. And after that, we are passing that test data set inside our data loader. Okay, and this test loader will pass to the model. Okay, or you can say that this test loader will pass to this evaluation method. Okay, fine. And also we are writing this criterion, or you can say the loss. Okay, cross entropy loss. Now we are loading the model as well, that we have saved in this model trainer artifact. So we are just loading it, torch.load, and giving the path of that, a map location device. So it's a CUDA compatible we are using, so we have to, is in this particular place CUDA will be there. You can see that suggestion is coming. So what this device will be, if your device will be having CPU or GPU, according to that this value will change. Okay, now we'll call model.eval. Okay, simple. And after that, what we are doing, we have to just generate the loss. Okay, the current model loss, the model that we have trained just now. Okay, on that particular model we are calculating the loss. Okay, so the once the loss got calculated, we are storing in this particular variable. Okay, now what we are doing, we are fetching the best model from Google Cloud Storage. So as of now, we don't have any models. Okay, in our Google Cloud, if I can show you, so in this sign recog, there is no model is present. So but if we will be having this model like this one, so we will be getting that model from this particular functions that we have defined here. Okay, this particular function. So we will be getting the model, and that model will present inside the model evaluation artifact folder. Okay, and also after that, what we are doing, we are checking whether exactly that model path we are taking, okay, that model.pt file path we are taking, and we are checking where exactly that file is present in our this model evaluation artifact folder. If it is not present, okay, if the model is not present in the Google Cloud storage, okay, so we are going to accept our currently trained model. Okay, when the first time you will run this pipeline, at that time you won't be having any kind of a model present on the Google Cloud storage. So at that time what will happen, your currently trained model will push to the Google Cloud storage. Okay, else if you are having the model, we will be loading the model that is coming from the Google Cloud storage, and then we will be calculating the loss on top of that as well. Then what we are doing, we are comparing the loss. Okay, we are comparing the currently trained model loss as well as the best model loss that we have taken from the Google Cloud storage. What, let's suppose if the best model loss is greater than trained model loss, okay, then then the model will be accepted, okay, else it will be false. So what we are passing in this model evaluation artifact, so we are just passing a boolean value, true or false. If the model is accepted, okay, so if the best model is works fine as compared to the trained model, so if we are getting this true value, then only our model will be pushed to Google Cloud storage, else the same model, the best model, will kept as it is. Okay, we are not going to do any kind of a modification on Google Cloud storage. So what will present inside this model evaluation artifact, so let me write it as well here. Inside our model evaluation artifact, we are accepting only boolean value. So let me do one thing, I'll just hit. So model evaluation artifact is taking is model accepted value, and that is in terms of boolean, true or false. Okay, and we need to import that as well. So I'll just import it, model evaluation artifact. So now you can see that. So that's all about this model evaluation pipeline. So that's in. So now we need to run this model evaluation, and before running it we need to mention it inside the training pipeline as well, training.py file, because it is a part of training. Okay, so I'll just mention it here. So before that we need to import few of the things, like model evaluation we have to import from src.components.model evaluation. We will be importing model evaluation class. Okay, and also we need to write it here as well. So we need model evaluation config as well, that we will be calling here. Copy it. So self.model evaluation config, and we will just paste it here and then give a bracket. Also it requires some. Now we'll write the function to start model evaluation. So I'll just write it and then I'll explain it what exactly we are doing here. So this is the thing, remove unwanted space. Okay, and also we need to import this model evaluation artifact just like config. So, model evaluation artifacts. Okay. That's enough. So what we are doing in this start model evaluation, we are taking two parameters, okay, model trainer artifact and data transformation artifact, these two things. So, okay, now we are calling the model evaluation class, this particular class we are calling model evaluation we are calling, and if you can see three parameters it is asking, like model evaluation config, model trainer artifact, and data transformation artifact. So we have given this one. Now what we are doing by using model underscore evaluation, we are calling this initiate model evaluation function. Okay, once it got initiated, so what this function is returning, it is returning the model evaluation artifact, and that we are storing it here. Okay, and that we are returning as well. Okay, Now we need to run it, so we'll write in the run pipeline, like we need to mention there model if model evaluation artifact. We have to start the model evaluation, and we'll provide the parameter model trainer, and this one artifact and model information. Now the thing is that we need to test it whether we are able to evaluate our model or not. So first thing what we'll do, I'll just save it and then I'll run the pipeline. Just write the python, then main.py we need to run. Okay, so let me run this one. As it is taking data from this Google Cloud storage, so you can see that it is downloading. A new artifact will get generated. If I'll reload it, you can see the new artifact is getting generated. So the data ingestion artifact is done. Now the training part is started. Okay, so we need to wait. Okay, it will be completed within a minute. It will get completed. Just wait for that. Training is started. As we have taken the epochs one only for as of now, one. You can train it for more number of epochs. You need to just do changes here. Epochs 10, 100,000, whatever you want, you can write it and it will be done. Okay, fine. So I think the training is done. Now if I'll reload it, now model training is done. Now evaluation part is started. Okay, so what we are doing here, okay, in model evaluation you can see the best model folder got generated, but as of now we are not having any model in this particular bucket. This sign hyphen record, the model.pt is not present, so we are not able to get anything. Okay, so we are not able to get inside this best model, so evaluation happens. Now the thing is that once the model evaluation is done, right, now we need to push our model to Google Cloud Storage as well, right? So it's a new pipeline that we need to discuss. So in this video we'll be ending this model evaluation. In next video we will be discussing about the model pusher pipeline. Hello everyone, welcome back. So in our previous video we have discussed about our model evaluation pipeline. So in this particular video we will be discussing about the model pusher part. Okay, so what we have to do, we'll just create one new file inside our src inside components. So will be a new Python file that we need to create, and that file name will be model pusher.py. So this will be the file name. Okay, I'll cancel it as of now. So now in model pusher, simply what we need to do, okay, we have to take the model from our model evaluation folder, or maybe from the model trainer artifacts folder. Okay, and we have to push it to the Google Cloud Storage. Okay, if our currently trained model will perform better than the model that is present on the Google Cloud Storage, then we'll push that model to the Google Cloud Storage. That's the thing we have to do. Okay, and we have already completed till this model evaluation part. Now simple code we will be writing to push the model to the Google Cloud Storage. Okay, so we will be importing few of the libraries. So I'll just write it, import sys. We will be requiring logs as well that we need to maintain. Import from logger, sorry, from src.logger import logging. Okay, and then from exception also we need to write exception, import custom exception. Cloud syncer also required because we need to push it. So src.configuration cloud syncer, then cloud sync storage. Also we will be requiring the model pusher config. So what I'll do, before starting model pusher component, what I'll do, I'll just create the config, okay, that what all configs required for our model pusher pipeline. Okay, so I'll write it and I'll explain you what all things is required. So very basic things are required, not much. Okay, so we need to read the YAML files. Few of the parameters will be written in this YAML. Second thing, we need a model name, okay, which model we want to push it, and and another thing that is required, that is bucket. Okay, where exactly we want to push it, which bucket. Okay, that's thing. And what will present inside the config.yaml, that also I'll write it and I'll explain you that as well. So only one thing is required, that is bucket name, nothing else. To push the model, we need bucket name as only, nothing else we will be requiring. Okay, fine. So I'll just import that as well, src dot entity dot config entity import model evaluation config. Okay, now what I'll do, I'll just create a function with the name of model evaluation, sorry, model pusher. Sorry, even I need to sorry, by mistake I have written model pusher config will be there. Okay, now we have to create a model pusher class. We'll define the init part. What all parameters it will take? It will take first parameter as a model pusher config. So I'll just write it here, model pusher config, and then we'll call model pusher. Another thing will be requiring, once our, let's suppose our model, we need to push our model, right? So from where we'll take that model? We'll take that model from our model trainer artifacts. Okay, so we have to import that as well, as src dot entity dot artifact entities and model trainer artifacts. Okay, so I'll just write it, model trainer artifact. So this thing is important. Now I'll write docstring as well. That is also important. We need to keep this thing as well. Model pusher config and model trainer artifact we will be requiring. I'll just define them. Model pusher config for this one, model trainer artifact, and Google Cloud Syncer, just to use when we have to push our model to the Google Cloud stores. Now we will be writing a simple one function will be there inside that, whatever things we will be requiring, I'll write it. So initiate model pusher we have writing, and it will return the model pusher artifact. So even the model pusher artifacts that we need to define inside our artifact entity. So I'll do one thing, I'll define it that as well. So only one thing is required, and that is artifacts that we are generating is the bucket name, nothing else we are generating, only the bucket name we will be saving as an artifact from this model pusher artifact. Okay, and we need to import that as well. So model pusher artifact. So what we are doing inside this model initiate model pusher, so first thing is that we are just trying to fetch, okay, sorry, we are just trying to push sync our file to Google Cloud. So we are uploading the model to the Google Cloud storage, and for that the parameters that will be requiring, that a bucket name and where exactly the file is stored as of now. So the file, the model that we have trained right now, so that is stored inside this model trainer artifacts dot trained model path. Okay, so it will upload that model.pt to Google Cloud storage, and it will generate the artifact, only the bucket name, okay, in which bucket exactly it is pushing our model. So we are keeping it in the artifact folder. Okay, now we need to run this model pusher pipeline. So we, as it is a part of training as well, so we need to define it here as well. So first of all, we need to import some of the things like src dot components dot model pusher. We will be importing model pusher. Okay, that thing also we need to mention it here. Model pusher config will be there, and model pusher artifact will be also there. Okay, now we need to define it here as well. So I'll just write it here, model pusher config. So it will be self dot model underscore pusher dot underscore config. and we need to write start model pusher function as well to start model pusher. So I'll just write it and then explain you what all things required. So this is a start model pusher function. So it requires only one parameter, model trainer artifact. Okay, because we are going to push model from the model trainer only. Okay, so we are calling this model pusher class, this class, and this requires two parameters. Then first is the config, model pusher config. Second is the model trainer artifact. Okay, after that what we are doing, we are just initiating the model pusher, this one we are initiating. So inside that, what it is taking, it is taking the bucket name and train model path, and it is pushing to the Google Cloud Storage, and it is returning the artifact, and the artifact will be the bucket name, where exactly. Okay, now the time to run this model pusher component. To run this, what we have to check first, like whether the artifacts generated from this model evaluation artifact is true or not. As in you can see in the model evaluation artifact, we are storing is model accepted is true, like we are storing a boolean value. So if our currently trained model is better than the model that is present on the Google Cloud Storage, then only we will run this model pusher component. Okay, so we'll write the one statement for that, if a statement. So if not model evaluation artifact is accepted, okay, if not it is accepted, then raise a exception like trained model is not better than best model. Else, if trained model is not better than best model, then we won't push anything. Else, what will happen? Model pusher artifact will run. Okay, and once the model pusher artifact will run, it will generate a artifact and the artifact is bucket name. Okay, so that's all with this model pusher pipeline. So what we need to do now, we need to run it and check whether this particular component is running perfectly or not. So what we need to do, we need to just write python then main.py, and I'll hit enter, and we'll have to wait it. I'll make it big so that it will be visible. So it is loading the data, sorry, loading the data from Google Cloud Storage. You can see that. Now the training will start. If we can see that as well, if we can reload it, so you can see that the artifact is generated, data transformation is done, ingestion artifact is also done. Okay, now training got started. Just wait for that. Okay, now you can see that it is not able to fetch model from the bucket because the model is not present right now, because the first time we are training and pushing our model. So the file is, now you can see that the model is pushed to Google Cloud Storage. If you want, I can show you that. Like, this is the bucket name that we have created. If I'll click here, and I'll have to refresh it as well. Okay, I think by mistake I have given some different name. Let me check what's the issue. Okay, I have given the wrong bucket name. Okay, the bucket name will be this one. Let me run once again the project. Okay, let me run once again. The model was pushed, but it got pushed to the different bucket. Okay, so I'm just training once again, and it will be pushed there. Started training. Now model is getting pushed. It's got pushed. Now what we'll do, I'll just check it 1 second whether it got pushed on. We are in the sign underscore hyphen record bucket. I'll refresh it. Okay, now you can see the model got pushed here, and it just now got pushed. Okay, you can see the date. Okay, so it just now got pushed. Okay, so we are done with this model pusher pipeline. So that's all for this particular video. Hello everyone, welcome back. So in our previous video we have discussed about the model pusher pipeline. So in from that pipeline we have completed our complete training pipeline. So what we will discussing in this particular video, we will be creating a web app by using FastAPI, and we will do the training through that one. Okay, so what we have to do, we will be creating one Python file. The name of that file will be app.py, and whatever things related to the UI part we will be writing inside that FastAPI part, we will be writing inside this one. Okay, so now if I'll refresh it, so you will be able to see app.py file got generated. Okay, so now we need to write few things here before running this app.py. So we will be importing some of the libraries, okay, related to the FastAPI. So I'll just write it and then explain you these things. We will be writing like the FastAPI we need to import, as we have already installed this FastAPI in our requirement.txt file. You can see that FastAPI and UVcorn is mentioned there, right? So that's what we are importing here, FastAPI, UVcorn, and inside that multiple libraries that we are going to use, like response or JSON response. Even though we need this app host and app port, like which exactly URL host means, like exactly at which URL our app will be running and at which port number, so that we need to mention inside our constant. So first thing that we will doing, we will be mentioning this thing in the constant file. So let me open our constant. Okay, so if I'll click on constant and init.py, okay, so what I'll do is it will be a kind of, so let me mention it here downward, or maybe I'll mention it in this part, because even this one is a common constant. Okay, so app host and app port. So now if you will see here, now the error is gone. Now there is no any red mark here. Okay, and just forget about this prediction pipeline, because as of now we haven't discussed about the prediction part. So maybe later in our later videos we will be discussing about the prediction pipeline. So in this particular video, what we have to do, we have to do the training part by using FastAPI. Okay, so the things that we need to write it inside that. So first of all, the what we need to write, we have to mention there, just like flask app, even we need to mention here as well, fast app is equal to fast API. Okay, and also we need to mention the origin. So origins will be like that, so that hashtag we have to give. So that's the structure of FastAPI. Okay, app dot add middleware, and inside that we need to mention other things, like whatever things we have imported. Okay, that thing we need to mention there, like course middleware is there. Allow origin, inside that let me write it here, allow underscore origins, and that will be origin that we have defined right now. And allow credentials is also there, so credentials, that will be true. Yeah, so credentials are allowed. Okay, allow method, so we will be using post and get method, right? So we need to mention that as well, allow methods, and that will be also, we need to mention that hashtag there. And after that, allow headers as well. Yeah, same thing we need to mention. Okay, that's fine with that. Now what we need to do, we have to create an app. Okay, we'll just write here app.get. Okay, and what we need to do, we need to train it, right? So we'll just give it a name, train, and inside that we'll create a asynchronous function. async def training with the name of training. I'll just write it here. Okay, and inside that, what we need to do, first also we will be writing the exception. Okay, so here we are not using our custom exception, normal exception that we are going to use it. So what we will be doing, training pipeline will be there, and we will be calling the train pipeline that we have imported here, training pipeline. So we need to call this particular function just to train our model, right? And to initiate the training pipeline dot run pipeline function we have already created there. So, and once the training will be finished, so then we will expecting one response. Okay, so return response. So I think I need to write it this way, and in response what we will be writing, training successful. That will be better. Training successful, like that. All right. Okay, and also we need to mention the accept condition. So accept exception as e, and what will be in the return when the exception will occur. The in response, what we'll get, we'll simply get message error occurred, and due to what, for that I'll just mention e. So whatever will be the error, it will be go inside that. Okay. Okay, so this is all about the training pipeline. Okay, so what we will be doing now, we'll simply run this app.py and we'll check whether we are going we are able to train our model or not. Okay, so what I'll do, I'll just simply save this one first, save all, and now I need to do what, I need to run this app.py. Yes, app.py while running, so it will take few minutes, a few seconds only, not few minutes. Okay, so it is not returning anything. Okay, there is one thing is missing here, so we haven't just written the main part, so that's the thing it's not able to do. So main is there, we need to call this app. Okay, and then we have to mention the host name, like the URL and the port number. Okay, so that's what we have already defined over this in this one. So host will be this one and this will be the port. Okay, exactly. So I'll run it once again. So now you got the URL, so let me copy this one. Copy option is there. Yeah, copy is there. Now I'll open the browser and then I'll paste it here and hit enter. So what we need to do is the FastAPI. So FastAPI is there, so sometimes it won't work with this 000. So instead of that, we can try with the local host or maybe this one. Okay, now you can see it's working, and we have created a function here. So synchron function was there, like train. So we have to just click on that, and then I'll click on this try out. Once I'll execute it, so you will be able to see the training will start here. Okay, so what I'll do, I'll just click on execute first. I've executed it. So now if you can see here in this so now our training got started. Let me do this one. Okay, so now you can see the data set is loading from the Google Cloud storage, and soon it will start the training as well. So it will take a few minutes, I think. Okay, so we'll wait for that, and then now even training is started. I have just given the one epoch in the config file. You can see that, just to save some time. Okay, so one epoch is there. You can mention whatever you want. Here you can see it's loading, and here it is executing. Everything get executed here. It will take some time. Now training got started. After that, evaluation will be done. So now if I'll click here, you can see there is an exception raised. Okay, model training is done. The exception what it is raised, train model is not better than the best model. So because of that, it raised the exception. We have already done with the model evaluation part, like, but in the model pusher part, what happened, the model that we have trained just right now, okay, it is not better than the model that is already present on the Google Cloud Storage. Okay, so because of that, the model pusher didn't work. Okay, so if you will train your model for more number of epochs, so it will be able to push your model, and then your training will get successfully. Then you will get a message here, training successfully. Okay, so that's all for this particular video. Thank you. Bye bye. So what we need to do first, we will be just open this pipeline, and we have to create one Python file there, and the Python file name will be prediction.py. Let me write it here. So what exactly, like in this prediction.py that we need to do is very simple. What we have to do, first of all, whenever we'll call the prediction pipeline, so what it will take image from the user, and then what it will do, it will download the model from the Google Cloud Storage, and it will pass that particular image to that particular model for prediction. And once it got predicted, it will just tell us like whether that particular image is original or forged one. Okay, so that's only the thing that we need to write it. Okay, so we will be importing few of the libraries related to that, so I'll just write it and I'll explain it. So these are very common libraries, like says they are a PIL image, just to read the image. Okay, and also we will be importing everything from the constant. Okay, logging is important, custom logger that we have, and from torch vision we are using this transform as well. Okay, we need to transform our image as well. So, and also we will be requiring the custom exception, and also we required something from our config file as well, so config.yaml file. So we need to write some of the parameters from there as well, so we will be defining later on. Okay, and also one thing that I have mentioned here, this one, from src dot configurations dot gcloud syncer import gcloud. So that's one. Also we, so what you need to do, instead of configurations it is, so because of that it is giving us error, nothing was there. Now what we need to do, we'll simply create a one class. Okay, and before that I'll just write whatever things will be required for this particular prediction pipeline. So in this YAML file, what we need to write it, we need to write the bucket name. Let me write it and I'll tell you. So for prediction pipeline config, we will be using a image. Okay, and once the image will be provided by the user, and that image will be saved to our local. Okay, and the name of that particular image will be input.jpg. Okay, and after that it will take the model from this bucket. So let me modify the bucket name. Okay, and the model, and from the bucket the model will be model.pt. Okay, and threshold we are keeping it 0.3. Okay, now go to the prediction pipeline, and now what we need to do, we need to create a class. Okay, so I'll simply write it, prediction pipeline, and inside that we need to call these things. So I'll just write it and I'll explain you. Okay, we will be requiring the Google Cloud Syncer. Okay, just to get the model from the Google Cloud Storage, and also we need to read the config file. For that, read YAML file function is important. Okay, and also from the data config, we will be requiring the image size. Okay, so image that we are going to, like, if from here. You can see this one, data transformation config. We will be taking the image size, so whatever image we are providing, so that image should be converted in this particular format or size, you can say. Okay, now we'll just create a function first. Okay, so the first function that we are going to create here is that the image loader. So once the user will provide the image, so we need to load that particular image to our local system, and to loading that image, we have written this particular function. So once the image will be provided, that image will be in the byte format. Okay, and we need to save that byte image to local. Okay, so what we are doing, we are just what this is the image. Okay, we are just taking a input image name. Okay, and whatever image it has taken in the byte format, we are saving it. Okay, so once this function will run, so what it will do, it will create in this particular, inside this signature recognition, there will be a file present with the name of input image.jpg. Okay, that's the use of this particular function, just to load the image from FastAPI and convert it, save it into the local. And after that, what we need to do, we need to get the model from our Google Cloud storage as well. Okay, so this function is for that only. So what we are doing in this particular function, simple, get model from gcloud. Okay, so we are making a directory first. Inside artifact, we will be making a directory with the name of predict model. Okay, inside that, the model.pt file will be kept there for prediction. Okay, so what we are doing, we are just passing there the bucket name. Bucket name is also already mentioned there in the config.yaml file. That's the bucket name, and this will be the file name that it is going to fetch it. Okay, and where it will be stored, and it will be stored in this predict model path, and that model path is nothing but inside artifact there will be a folder with the name of predict model. Okay, and it will return the best model path. Wherever the model will be stored, it will return the path of that. Okay, and after that, we will be writing the prediction part. Okay, so what we are doing in the prediction part, when we'll call the model.predict, so what will happen inside that, so that also we need to define it, right? So for that, I'm writing here. Fine, so what we are doing here, we have defined the predict function, and it takes two parameters. First is the image path, you can say, and the best model path as well. So we are loading that particular model. Okay, and based on the device, whatever device you are having, CUDA or CPU, and then model.eval we are calculating, and then what we are doing, we are performing some kind of a transformation on that particular image. Okay, we are converting that image into some kind of a size, and the size is 224 cross 224. Then we are converting that grayscale. Okay, and then tensor. Okay, and so we are performing this preprocess inside that image we are passing. That's one. Now we are converting that image with respect to our device like CPU or CUDA. Then that particular image will be passed to our model that we have taken here. So in this particular model, image is getting passed, and then we are going to get the probability. Okay, but like what will be the probability, like it will be in the form it will be in between 0 and 1. Okay, so like if it is more than 0.5, then it will be related to the positive, or maybe you can call that the original one. Okay, so the label name we haven't defined, so I think label name I need to define inside our constant. So let me define it that as well. So because of that, it is giving is the red mark. Okay, so what I'll do, these are our labels, forged and original one. Okay, original. So now if you can see here, this one, the error is gone. So simple thing is there. Okay, we are predicting it. Okay, and after that we are mapping the labels, and then we are simply returning the label name. Okay, exactly which class it belongs to. Okay, that's in for this prediction function. And then what we will be writing here, there will be a run pipeline, so that will help us to run all the functions that we have created till now. So inside this run pipeline, what we are doing, we are first calling this image loader, and then once the images get loaded, then we are calling this get model from gcloud. So then model will be loaded from Google Cloud storage. Once the model is loaded, then that model path is provided to the prediction function, this particular function, and the image as well. And once this image got, like, the label is once it returns the label, so even we are returning the label. Okay, that's in for this prediction.py file. Now what we need to do, we need to call this particular prediction.py file in our app.py. okay, just to integrate this thing with our FastAPI, what we need to do, we will be creating a function. Okay, so let me write it and I'll explain you what we have to do here. So in this prediction, so even though we need to import it, the prediction pipeline, so the prediction pipeline is inside our src.pipeline.prediction. so now you can see there will be one space, so fine. So we are calling a synchronous function prediction. Okay, and inside that we are calling this prediction pipeline, and that is this one only. You can say this prediction pipeline class we are, and inside this class we will be having a function called run.py, run_pipeline. This function is getting called, and inside this particular function image file is passing. Okay, so the image that is taken by the user from the UI part. Okay, so what we need to do now, we'll simply save this one, and now what we need to do, we'll simply run this file app.py. So now it's got running. So what we need to do, I'll simply go here and then go open it. Now we can see earlier it was only showing us the training part. Now even the prediction is showing. So I'll simply click on that and click on try out. We need to select the image. So what I'll do, I'll just simply select one image, click on open, then execute it. So now if you can see in this part, so you can see the model is getting downloaded from the Google Cloud storage, and it will be stored in this one. As I said, it will be stored in our artifact folder, and inside artifact there will be a folder that will be getting generated with the name of predict model. Okay, so you can see the model is getting downloaded, and after that prediction will happen. So you can see this one, forged one. Okay, so but the image that we have taken, that is from the original one, you can see there, but it is giving us the prediction as a forged. So because the model we have trained, that is not trained on more number of epochs, it's just a one epoch that we have trained it. Okay, so that's all for this prediction pipeline. Okay, we'll talk about the rest of the things like Docker image or Airflow integration in our next video. Hello everyone, welcome back. So in our previous video we have already talked about the training and the prediction pipeline. Now what we have to do, we have to deploy our project on any of the cloud platform. But before deploying the project, first what we need to do, we need to create a Docker image of this particular project. Okay, so just to create the Docker image of this particular project, we will be requiring a Docker file. So what we will be doing, we will be creating a Docker file, and inside that we will be writing some of the commands to create a Docker image of this signature recognition project. So let's go ahead and start doing that. Okay, so what I'll do, I'll just create a Docker file first. So touch Docker file. Okay, this is the one way to create it, and you can do it by using this one UI part as well. Like you have to just right click on that, click on new, and just click on the file and write the name Docker file. Okay, and make sure Docker file doesn't have any kind of extension. Okay, the file name will be only Docker file, nothing else we have to mention there. Okay, so as we have already mentioned here, touch Docker file, so a Docker file will get created here. So if I'll just reload it, so you can see the Docker file got created here. Now we need to think like what all things we need to write inside this one to create a Docker image. So let me open this one first. Okay, so as we all know, in this particular project we are working on the Google Cloud. Okay, like we are getting the data from Google Cloud Storage, GCP, right? And also even though we are pushing our model to the Google Cloud Storage, right? So instead of so what we are thinking, okay, just create a image, create a Docker image of Google Cloud Storage, so that we don't have to think more about the authentications. Okay, so what I'll do, I'll create a Docker image of Google Cloud. So from Google / Cloud SDK latest. So the image that will be get created, and that image will be of Google Cloud, and inside that image what we are going to do, we are just creating our own work directory. Okay, and that work directory will be sign. So there will be a folder will get created, and inside that folder all the files will be copied. Okay, so we need to write that as well, copy dot space slash sign. So everything, whatever things will be present in our current working directory, like this one, whatever things like artifact, config, log, no, notebook, src, whatever things are there, right? So everything will be copied in this particular folder. Okay, so in our work directory. So once we have created a work directory and we have copied all of the content inside our work directory, now what we need to do, whenever we are, as you know, like this Google Cloud SDK image is a kind of a Ubuntu image. Okay, so we need to do some of the updates there, right? So apt update -y. So just -y we are mentioning, like, so that it won't ask us to approve, like yes, no, or something like that. So because of that we are just writing -y. So we are already giving him a permission to get executed. After that also we need to update some of the things. So I'll just write it everything here and then explain you one by one what all things will be required. Okay, apt update, and then also we need to install pip upgrade. We need to upgrade the pip as well. So pip upgrade and sign, then again a slash. That's it. There won't be a space. We don't need to give that space. And after that one more will be there, apt-get install ffmpeg. Don't worry, I'll explain it what exactly it is. These are the important libraries, okay, because it's the Ubuntu image, so we need to update these things. Okay, then only we will be able to create the container, a good container. Now, so these things will be installed. Okay, and after that what we are using here, Google Cloud, right? So we need to authenticate our credentials as well. So for that also we need to install some of the things. Okay, so we will be writing apt-get and then install, let me write it, apt-transport. This thing we need to do that, apt transport https ca certificates gnu y. And one more thing that we need to install is, that is Python. Okay, because it's the Python based project we are doing. Okay, and after that what we have to do, like if you can see in the requirement.txt file, I didn't mention about the PyTorch package, as I have already told you, like it depends upon the system, right? Like in Docker image definitely we don't have the GPU, so we'll go for the CPU image, right? So CPU version of the PyTorch. So I'll just write it there. So what it will do, it will install the PyTorch, and that too CPU version of it. Okay, and the rest of the things will be installed from the requirement.txt file. And after that pip install -e dot, just to create this src as a package. Okay, so this src will work as a library there. Just to install that we are writing here pip install -e dot. Once everything is installed, now what we need to do, which file will get executed first, right? So let's suppose we have created that Docker image, right? So now we need to tell Docker as well, right? So which file you need to execute when I'll run that Docker image, right? So we need to run this app.py file. Okay, because this is the main file. Everything, whatever things like related to training and prediction, everything is written inside this app.py file. So we need to tell Docker image, right? So this particular file you need to run, and this particular file is a Python file. Okay, so now we have created our Docker file. Now what I'll do, I'll just simply save it, and we'll test this Docker image, like whether this particular Docker image is working or not. So just to run this particular Docker image, you should be having Docker installed in your system. I'm not going to show you the installation part, but if you are using Windows, okay, so let's suppose if you are using Windows, so let me show you how you can install it. I'll just Docker install Windows. So this one you need to install it on your system. Okay, steps are already mentioned there for Windows and for Linux, whatever distributions you are having. Okay, according to that you can install it. All the steps are mentioned there. Okay, but so I have already installed Docker image. So if you can see, so if I'll show you, so this is the Docker. This is my Docker. Okay, it's still running. You can see the engine is running. So what I need to do now, I need to build that particular image. Okay, so just to build this particular image, we need to write a command docker build -t, and we need to give a image name. So I'll just give, because it's a signature recognition, so I'll give it sign and then give a space and then dot, and then I'll hit enter. So it will start building the image, and it will take some time depending upon the image size. So we have taken the Google Cloud SDK image, so it will be something around 7 or 8 GB. Okay, and it completely depends upon your internet speed, how much time it will take. So what I'll do, I'll just pause the video for a few minutes. Okay, once the Docker image will get generated, and then we'll start again. Okay, yeah, so it's done now. So if you can see here, it took almost 446 seconds to complete the installation process, or you can say the Docker image creation process. So almost 7 minutes or something, like 30 seconds, something around that it took. Okay, so now I'll just go to this Docker. Okay, now you can see a Docker image got generated with the name of sign. Okay, you can see that. Now what we need to do, we need to run this Docker image to test whether the Docker image that we have created, is it working or not. So let me clear this terminal first, and then I'll write the docker run command. So it's docker run, then a space -d, -t is for port. So I'll just map the port, because as you can see in the app.py file, this is the app port. Okay, and this app port is mentioned in this constant file, right? So it's 8080, so we are mapping the 8080 port with the 8080 itself. Okay, and now what we need to run, we need to run the image. So we have to give the image name as well. So the image name that we have created, that is with the name of sign. So I'll just hit enter. So you can see that now it's got running. So if you can see now, this is the image. If I'll go click on the container, you will see there will be a container running. So you can see here, this container is running, and this just got run 10 seconds ago, right? 14 seconds ago, right? So what I need to do now, I'll just simply go to the URL and just check it whether this particular thing is running or not. So it is running on port number 8080, and as it is a fast API, so we need to write /docs. So if I'll hit enter, you can see this API we have already opened our this fast API. Now what we'll do, we'll just simply test it whether the image is working or not. So we'll go with the prediction. So I'll just click on the prediction, try it out, select some image. Okay, so I'll just go there and then select some image from our project. Okay, maybe from where exactly the image will be there. Yeah, I'll this one. Okay, I'll just take a image. Okay, and simply execute it. So you can see okay, so there is an error here. Okay, let me try to fix it. Okay, let me try to fix it. Okay, so you can see we are getting the error, the predict model and /model.pt. So the thing is that we are not able to fetch the model from this model.pt. So what we are missing here, so let me tell you that. Okay, so we'll go to the image first. Okay, I'll click here, not to the image, click on the container. If I'll click here, I'll open a terminal. Okay, what we need to do now, okay, as of now, what we have to do, we have to fetch the model from the Google Cloud storage. Okay, but we haven't provided the credentials where exactly it has to fetch the image, like model. Okay, so in the readme file I have already mentioned there. So what you need to do, okay, whenever we will run the Docker image, so first thing that we need to do is this one. We have done it, right? This one to just to open our Docker image in the interactive mode if you are using a Ubuntu. Then because if you're not using a, if you are using a Windows one, then it's already opening in the interactive mode, so then you don't need to use this one. After that, we need to authenticate our Google Cloud, okay, storage. So I'll just copy this one and authenticate it. Okay, if I'll click in here, so now I'll got this URL, I'll have to just open there. So once I'll open it, okay, it will ask for the authentication, so I'll just need to enter the password. Just give me a second. Yeah, so I have entered the password, and after that it is asking me to like allow all of these services, so I'll just simply click on allow. So you can see that we are getting this one, so I have to just copy this one and paste it here and hit enter. Okay, that's the thing. And another thing was there that also we need to mention it, this one, Google Cloud Application Authentication. So that also I need to copy it, just paste it here, and I'll get the URL. I'll just click on that, allow, copy it, paste it here and hit enter. Okay, now it's done. Now what I need to do now, I will again execute this one. So I'll just simply refresh it, click on try it out, select one image again, click on open, then execute. Now wait, it will take a few seconds to load the model from Google Cloud Storage, and then it will give us the prediction. Just wait for a few seconds. Okay, so now you can see that, okay, we are getting the prediction. Yeah, I know that it's not correct, but because the model that we have trained is just for a one epoch, we need to train the model more for more longer duration. Okay, so we have tested like the Docker image that we have created, it is working perfectly fine.
Hey everyone, welcome back. In this video, we will be learning how to create our workflows file for GitHub Actions, so that this GitHub action will make use of this workflow file to initiate our CI/CD pipeline. And I'll also add few videos on how to set up your GCP account and creating our artifact registry and creating our Google virtual machine. In those videos, you will also learn how to set up self-hosted machine in GitHub so that our GitHub actions will deploy our project on the self-hosted machine. Now, before creating our workflow files, we have to create our Docker file so that whenever your CI/CD pipeline is triggered, your GitHub actions will make use of this Docker file and build an image so that it is pushed into artifact registry. From artifact registry, we will be making use of this image and then run it on our self-hosted machine. Now, let's start creating our Docker file. For that, let's open our project, and under your root folder, we can create a file called Docker file. Once you create this Docker file, we can write all this command and then I'll explain you. So these are the Docker commands. The first command is from Python 3.10. Because we are using 3.10, I just took that image with Slim's bullseye, which means we are using smaller size image than the regular image, so that our image size will be lesser than normal. Next, we are running this command apt update so that we will get all the latest updates, and we also install this utility for our project. This ffmpeg is a utility function which is used to load your audio data. And the third command is we are just installing AWS CLI so that you can use all these S3 operations. Next, we will be creating our working directory, which is app, and we will copy all these files to our folder. Next, we will run this command to install all the requirements from our requirement.txt. Next, we will run this command to start our application in Docker image. The next step is we will be creating our workflow files. To create our workflow files, go to your root folder and then create a folder called as .github. Under this folder, you can create one more folder called as workflows. Under workflows, we can just create our YAML file, which is gcp.yaml. This is our gcp.yaml file. Here we will be writing our workflows so that it initiates our GitHub actions. So let's start by giving the name as workflow. And the next step should be on which rule your GitHub action should get triggered. So for that, let's write on push. So every time you push, your GitHub action will get triggered. Push to which branch? This can be given as main. So if you push your code to main branch, automatically your GitHub actions will get triggered for that repository. But you don't want to push for every commits. In case you don't want to push, if you are committing your code to readme file, so it can be given as paths ignored. This is readme md. What this will do is it will ignore all the pushes you make to readme.md file. So the next step is jobs. Under jobs, we will be giving our continuous integration and continuous delivery jobs. So I'll give this name as integration, and under integration we can just give name as continuous integration. So this is our integration. After name, we are just giving Ubuntu latest runs on Ubuntu latest, which means this job will run on Ubuntu latest machine, which is provided by GitHub Actions. And the next step is we'll be providing steps. Under steps, we have name, which is checkout code, and this actions will check out all the code from your repository. And the next step is we are just linting the code. For linting, I'm just echoing out, and for the same, there is no test in our project, so that I'll just print out test complete. So all these steps will make sure that your code is in continuous integration. So the next job can be build and push to GCR. So what is GCR? GCR is our artifact registry which we created while we created our GCP account. So let's give this name as build and push to GCP. So this is our build and push GCR step, basic step. I didn't write completely. Here we just give name as build and push to GCP. The next step is we are just giving needs. So this job needs integration to be completed. If integration is not completed, this build and push GCR won't work. And next we are giving runs on Ubuntu latest. Even this step will make use of our Ubuntu latest machine, which is assigned by GitHub action. Next, we are creating our environment variables. They are repository, image name, image tag, project ID, and location. All this information can be taken while you create your artifact registry. And this is your repository name. And the image name is what image name you want to build. Image tag is your own interest. I have given latest here. And project ID can be seen in your GCP account. In our case, this is project neuron. And GAR location is Google Artifact Registry location is Asia South 1. Now let's start writing our steps under build and push GCR. Steps can be, so these all steps we need to do for build and push to GCR. The first step is checkout. Under checkout, we are just using the same actions, which is checkout v2, which we used in continuous integration. And the next step is authenticating with Google. For that, we will be using this action called as Google GitHub Actions auth v0. This is already provided by Google in their GitHub account. With credentials JSON, this authentication step will use these credentials which we have stored in our secrets of our GitHub account. And in the next step, we are just logging into our artifact registry. For that, we will use this step, Docker login actions v1. This is already provided by Docker in their GitHub account. And this will use our registry name and the username which is taken from this JSON file and the password which is taken from this secrets.gcp credential. Now we have logged into our artifact registry. The next step is Again, we have to authenticate our Docker to our artifact registry. For that, we will just give Google auth configure Docker, our artifact location, and Docker package dev. This command can be seen in your Google artifact registry. And the next step is, this is the important step, we are building our Docker image. To build our Docker image, we just give docker build -t, and this will take in our path exactly to our image. And the next step is docker push. This will push the built image to artifact registry. Docker push our image location. Now let's start writing our next job, which is pull and deploy. What this pull and deploy will do? This will pull image from your Google artifact registry to your self-hosted machine, and there it will run the code. This can be named as continuous deployment. So we have our continuous integration and our continuous deployment. This needs build push GCR. So this job needs build and push GCR to be completed. Only after this gets completed, our pull and deploy will start working. And this continuous deployment should run on our self-hosted machine, because that's where your image is getting deployed. I can name it as self-hosted. Next, I'll just give environment variables. These are exactly the same which we have written over here. So I'll just copy that. So now we have given our repository name, our image name, image tag, and project ID and location, just like how we gave it here. And then what we can do is, let's start writing the steps. So this is our steps in continuous deployment. The steps are, first we authenticate with Google Cloud. For that we will be using the same actions which we used. This will make use of our GCP credentials which we stored in our secret. Again, we log into artifact registry to access our Docker image. For that we will be using our registry name and our username and password. Again, we just log in, and this login is to configure our gcloud and Docker. The next step is, we are authenticating with artifact registry. For that we will just print this access token, and we just give Docker login and our password and our location. All this information is already provided in GCP documentation. The next step is Docker pull. To pull your Docker, you just write the command as docker pull and your location of image. Next, we can run our image. For that we will just give docker run -d, which is our detach mode, and -e, which is our environment variables. They are AWS access key ID. This will be taken from our secrets, so we will just paste it on our secrets. And AWS secret access key, this is also taken from secrets, and we will port map it to 80 port. Our application is running on 8080, and this is mapped to 80. And we can give our image location here. So this will run your Docker, and then your application will start running. Once our docker run command is initiated, our Docker will start running, which is our application will run. Once you click the external IP address of virtual machine, it will take you to the application. So the last and final step is, we will use docker system prune to remove the old images. Your virtual machine will have limited resource. Maybe it might have 20 or 30 GB. Your image will be around 5 to 6 GB. So in this case, as you keep on running this pipeline, your images may be stored in your virtual machine. To remove that, and then to make your system clean, we just run this function. This will remove all the old images which are not necessary. So that's it, guys. This is our final workflow. Now we will push this to GitHub, and then we can check if the GitHub action is initiated. If there is any error, we'll just solve it. To push that, we'll just open terminal. We can give git add all. Okay, before this we can also add docker ignore. This docker ignore is similar to git ignore. So here it will ignore all the given path so that it won't be used while building our images. We can also add downloads. Now that's it guys, we'll just add git add git status. We can just commit it now. This is our third push. This can be third commit. We'll just write git push origin main. So we have pushed our code to GitHub. Now we will log into our GCP account and then we will open our virtual machine so that it takes all the continuous deployment work. If you log into your GitHub account, you can see that our continuous integration is running and build and push GCP is happening. But right now I haven't added any secrets. So let's add secrets. So for that, let's click on settings and click on secrets. I think you can see it now. You go inside settings and then secrets. Under secrets, you click on actions. Here you can create our secrets. Now I will add all the secrets. Here our secret name should be exactly the name which we have given in our workflows. So let us open this. Here we have given it as GCP credentials. Let's copy this and then paste it. I will add my secrets which is JSON format and I will just click on add secret. Now I have added GCP credentials successfully to my account. Now let us create secrets for our AWS account to access our S3 bucket. For that we need 3 credentials. They are AWS access key ID. Here you can copy and paste your key ID. Now I have added my access key ID. Now I will add secret key ID also. For that let us go here. I just copy this. Under name we will add our secret keys and this secrets should be added. Now I have added all the required secrets. Now let's go to actions. We have our failed actions. Click this. Click here and then click on rerun failed jobs. All the works which is failed. It has successfully authenticated with Google. Now it is logging into artifact registry. Okay, I think we have given wrong name here. Yes, if you see here our docker file should be f should be small. I have given capital. I am just changing the capital F to small f so that it works. I just commit it, changed the docker spelling. Now I committed this. Now we can check our actions. Current commit action is running. Let us see that our continuous integration is also completed. Now let me click on build and push to GCP. So now our docker is getting built and the next step is once it is built, it will be pushed to artifact registry. Now our docker image is getting pushed. Now let us open GCP. We will open our virtual machine and then we can configure our self-hosted machine. So here language identification. This is my virtual machine. I'll just open this and we can start it. Once your machine is started, you can see this SSH option. You just click on it and click on open in window. This will open up your Linux machine. I assume you all have installed Docker and then configured all the prerequisite in your virtual machine. Now let us add our self-hosted runner. To add your self-hosted runner, you just open your GitHub account and click on settings. Under actions, you can see there is runners. Click on it. And here you click on new self-hosted runner. As we have Linux machine, you can click on this. So you copy paste all these commands so that your self-hosted runner will be configured. Now I have copied all these commands and then configured my GitHub actions. Now let's click on this run.sh and we can run it. So this will show you like connected to GitHub and listening for jobs. Now it is running the job of continuous deployment. Once you open action, here you can see our continuous deployment is running. Now it is currently pulling our Docker image. Next it will run it, and then it will do system prune to remove older images, and then it will do post authenticate. Our application will be running after that. And that's it guys, our deployment is done. We have done all these 3 steps, which is continuous integration, build and push to GCP, and continuous deployment. Once this is built and pushed into GCP, it will be saved in artifact registry. From artifact registry, we just do docker pull, and after that we will just run this image with the required command, and we will just prune the old images, and then we will do post authenticate with Google. Now we have successfully run our Docker image in our virtual machine and it is deployed. Now let us log into GCP and check our deployed application. Now I have logged into my GCP, and then under compute engine I have my virtual machine. Here you can just see this external IP address, copy this and then run it. And you can see here guys, we have successfully deployed our application. Now we can test it using any one of our prediction file. Now let us predict any one of these files. Let's click on predict, and yes guys, it has successfully predicted it as Kannada, and we have given a file which is Kannada language. And this is it guys, we have successfully deployed our application, and this project has lot of scope. You can improve it in many other ways. I have given few assignments so that you can improve on this audio pre-processing and other stuffs. And in the resource section, I'll be giving you this entire project in a zip file so that you can use it. I'll be giving you training data which has 1000 files and prediction data which has 100 files in each and every classes. You can also add this project to your resume. If you guys are interested in audio processing, this will be a great stepping stone for you. And that's it guys, all the best. We will be meeting in a new project.